Ladies and gentlemen, good morning. Thank you very much for coming here. We are not in very big number, but the best of us is here. So I think we can start. My name is Peter Szynkarczyk. I am director of Łukasiewicz PIAP Institute. We design and produce robots. One of them you can see at the entrance. This is one of our designs, which is in the service of in Polish Army. So this session is about artificial intelligence and robotics. So one of the robots is here, and probably we will see the interesting presentations also about artificial intelligence and robotics. So plan for today is, at first we will have this session, which we are opening now. And there will be several presentations, and through the presentation we move from more scientific to more practical applications of robotics and artificial intelligence. Then we will have discussion panel, and just before the lunch we will hear the success story from ITTI. One of us will present the real application and success story in European Union projects. So we will start with presentation from Professor Burczyński, who is here. And the title of the presentation is Artificial Intelligence in Design New Materials and Applications to Mobile Robots. So Professor Burczyński, floor is yours. And each presentation, 20 minutes.
Thank you, Mr. Chairman, ladies, gentlemen. The title of the presentation you see on the you see on the ekran. I prepared this presentation together with my co-workers, Dr. Michał Bereta, Dr. Wacław Kuś, Dr. Adam Mrozek i Dr. Jacek Szklarski. According to the beginning thinking about this presentation, I was asked to give some general information also on artificial intelligence. Of course, I will speak about application to mobile robots, but also I present some general information about artificial intelligence and give some remarks about the possibility of using this artificial intelligence technology to design new materials, exactly 2D materials, and one example connected with a biomedical application. Here is a typical definition about what is it, the artificial intelligence given by Minsky. As a science, it is according his thinking, it is science on system realizing tasks which require intelligence, or natural intelligence exactly, when are performed by human. Next. No. Okay. But if we talk about the natural intelligence, it is necessary to say what is it, because there are several definitions about it. I find some modern definition of intelligence as ability of adaptation to conditions due to detection of abstractive relation, exercise of prior experience, and effective control on own cognitive process. From this definition, we can distinguish three groups of problems connected with natural intelligence. It is ability to learn, it is ability to adaptation, and a very complicated aspect, metacognitive ability. I mean, the understanding of own cognitive process and ability to controlling them. The question is how much natural intelligence is in the artificial intelligence. In order to answer on this question, it is very convenient to introduce some criteria of artificial intelligence. As is written, it is convenient to formulate a criteria of artificial intelligence, which can be useful in evaluation of the level within the scope of artificial intelligence produces the natural intelligence. And it is possible to distinguish or formulate three criteria. One very simple criterion is the simulation of natural processes. And it is typical for well-known in the informatics, computer science, connected with the test Turing. The second criterion is the intelligence activities. I give some remarks about it on the next slides. And the most important is the criterion rational origination. I also give some remarks about it. What is intelligent activities? So we can say that we can distinguish two aspects of these activities, intelligent activities. It is an application of heuristics. It is typical for the human, and also very important, the ability to learn. But the rational origination, it is ability to computer system to initiating activities which are sensible in specified environment and next to effective steering these activities. We name the system is intelligent according to this criterion when it is an originator, not just any contractor of orders according to prescribed algorithm, when it is a rational originator, and when it is entity of its own activities. According the information, according also in my mind, this third criterion, rational origination, it is the most hard criterion of artificial intelligence, and present, according to my view, there is no system which fulfills this criterion. Now I would like to give some information according application of artificial intelligence-based algorithm method in engineering biomedicine in my institute, Institute of Fundamental Technological Research of Polish Academy of Sciences. Acronym of this institute is IPPT-PAN. So in our institute, we use the application of artificial intelligence algorithms to optimal design engineering system and classification and clusterization of biological and medical data. I show two slides connected with this aspect. The second is application of information theory and artificial intelligence in neuroinformatics. The most important from the subject of our session is application of artificial intelligence in the context of vision systems and mobile robots. And a very important aspect of our activity in this institute is application of artificial intelligence methods to image processing and recognition with the use of ultrasonic data. Some aspect of connected with the first step, I mean, first of all, design new materials, design new engineering system. I describe in these two books. One is published by Springer, Intelligent Computing in Optimal Design, the title of this book, and the second book, which published 2 years ago by Wiley, it is multi-scale modeling and optimization of materials and structures, and in this book we described the possibility of using artificial intelligence to design new materials, for example, new concept of graphene and other materials, 2D materials. Of course, when we talk about the algorithms and methods of artificial intelligence, we can distinguish several algorithms. First of all, I mean artificial neural network, evolutionary or genetic algorithms, artificial immune system, swarm algorithms, machine learning connected mainly with artificial neural network. But recently, as you know, is a very important active area. It is generative artificial intelligence system, which fall under the broad category of machine learning and neural networks. And such generative artificial intelligence aspects and algorithms such, for example, ChatGPT, can be used to create new content, including audio, images, text, simulation, and video. And this is the latest very important aspect and direction of the development of artificial intelligence, and with the potential to drastically change the way content is created. This example, which now I try to present, it is a possibility using such algorithms to create new materials, 2D materials, based, for example, on carbon. Using such algorithms, I mean mimetic algorithms, we can create new graphene-like materials, X and Y. X and Y, or new anisotropic size graphene. Now we are working on another possibilities to create new 2D materials based on, for example, molybdenum, silicon, tin, and another bismuth, for example, German chemical aspects of such new 2D materials. But I show only this one because it is more important, and using the algorithm which I present on the next slide, this mimetic algorithm is some kind of evolutionary algorithm together with gradient methods enables to obtain new possibilities, create new materials. And the second example is where we use the artificial immune system to selection and classification of ECG signals by using this artificial immune system, and it is possible to selection and classification such biomedical signals. It is very convenient approach to such problems. But let's go to the main aspect. I mean, artificial intelligence research conducted in our institute, connected with mobile robotics. Dr. Jacek Szklarski from this institute and his research group deals with such problems. First of all, it is object recognition on RGB or RGB deep images in order to improve a robot's knowledge about its position and use typical deep neural network-based approach. The second group of problems connected with the point cloud integration. I mean, the radars provided detailed information about distance of obstacle, I mean, in the three-dimensional problems, and in order to efficiently integrate these points into the maps, we use the artificial intelligence-based classification method. And the third group of problems connected with the path planning for multi-robot system. I show some two examples. The time is okay. For example, efficient 2D mapping. One of the examples of application is a mobile laser scanning system as a meaning survey system which facilitates fast and precise measurements. The resulting 3D model on the shaft after optimal matching procedure is given in this figure. The next, it is examples. It is industrial cleaning. In IPPT PAN, in my institute, worked with a business partner unit, United Robots, in the process of developing a fleet of cleaning robots designing to the cooperatively clean floor in large warehouses. And this next figure slide describe more detailed application industrial cleaning in very important area. Our research conducted in IPPT PAN is connected also with hyper-redundant robots manipulators and architectural optimization. We design modular systems which are composed of multiple identical elements. We use the partics from optimization I mentioned before as kind of artificial intelligence algorithm, and rapidly exploring random trees and other Monte Carlo techniques used in order to control modular manipulators. And we also use evolutionary or genetic algorithms to employ to optimize structurally and topologically these modules and to find optimal ways to connection to them. Here is some examples connected with hyper-redundant manipulators, and the second one also describes more detailed some techniques connected with this problem. Here is a skeletal modular ramp for pedestrian to use this approach. Because the time should finish my presentation, I give at the end 2-3 slides connected with the NTR's artificial intelligence techniques. We can observe, first of all, rapid development of artificial intelligence methods, especially application in many areas of science, including also mobile robots, and also essentially in areas of social life. And according to my knowledge, I mentioned about the criteria of artificial intelligence. So we can say that criteria of artificial intelligence in the scope of the first and the second criteria are fulfilled in large degree. But this third criterion, rational origination, is still open. There are several barriers of controversial issues connected also with the application of artificial intelligence algorithms and techniques. In my opinion, it's very important to develop new approaches connected with neuroscience, develop of advanced new algorithms, but very important aspects connected also with legal aspects and ethical aspects. For example, when we talk about the autonomous cars, so legal, ethical aspects is very important. It seems to me the last slides. So, future of artificial, of course, software engineering, computing power. As I mentioned, the progress in development of neuroscience, but it is also interesting view connected with Professor Nilsson from Stanford University. He introduced so-called human-level machine intelligence. It's a system which can handle majority human professions on the level of a typical man. According to his prognosis, there is 80 or 90 chances to observe such human-level machine intelligence 2,100 years. So this criteria, this human-level machine intelligence, it is very similar as the third criterion you mentioned, rational origination. So the dangers of the development of artificial intelligence connected, it seems to me, mainly on this third criterion. So we have about 100 years to be more nervous, expect some dangers. Thank you for your attention. Thank you very much.
Thank you very much. So if there is any very short and quick question, someone can ask. I don't see any. So maybe I will ask you, but please answer very quickly. There is some kind of a shift probably now we are observing, because in the past we were using, at this moment we can say classical methods. I mean localization, global path planning, artificial neural networks, genetic algorithms, and so on. So those are quite usually used methods. Do you think that after what we observe now, the rise of artificial intelligence, did it shifted the whole research on the mobile robots?
Yes, but I expect also, as I mentioned, so very important, the very important is the elaborate new algorithms connected with neuroscience. So I expect that we, in the future, we will new methods which will be very useful in the modular robots.
Okay, thank you very much again. So now we will move to second presentation. This one will be played from the video because Professor Skibniewski, who is the author of this presentation, at this moment is at the plane over the Atlantic Ocean. So we will play recorded presentation from Professor Skibniewski. So please play the tape.
Hello, this is Mirosław Skibniewski from the Łukasiewicz Industrial Institute of Automation and Measurements. This presentation is about the state of the art and practice in construction robotics. The idea of construction robotics is not entirely new. It has been first mentioned in 1910 during an industrial exhibit in Paris, France. The depiction is about the future construction site in the year 2000. So this was just an imagination of an artist who would envision that there would be a human-controlled robotic manipulator lifting cement blocks and stacking them up, building a brick wall. And the controls would be on the panel inside the booth, manned by a human operator. And the word architect is written on the booth because the word engineer wasn't commonly used at that time during the beginning of the 20th century for people involved in the conduct of work on construction site. So the question is the future going to belong to humanoid robots exhibiting superhuman capabilities? Again, it's an artist's rendering of what the future construction site may look like, but it's not entirely clear as to whether this particular vision will be materialized in any time soon. However, we do have a lot of interest in futuristic construction equipment that may resemble some humanoid capabilities, such as the one that is shown on this slide. A walking crane is an entirely possible vision if you believe the vision of Grove Manufacturing Company, the largest telescopic boom crane manufacturer in the United States, and that would be meant for very inhospitable environments that are difficult to reach by standard means of locomotion, such as wheels or tracks. And other developments are also in progress. For example, there is a very well-known company in Boston, Massachusetts, by the name of Boston Dynamics, that has produced a number of mobile robots relying entirely on legged locomotion, exhibiting, in fact, incredible capabilities in terms of ability to run, ability to jump, even flip. And to that point, the applications of these robots have been widely contemplated for varieties of industries, including construction, particularly inspection and demolition applications. There are a number of ways to classify construction robots. One way is to classify them by the level of complexity. So we can see that we can mention a wide array of robots from remotely controlled simple manipulators all the way to autonomous robots that are able to reason about their own work environment. And in construction, that's particularly important because the environment changes significantly as the work progresses. We can also classify robots by the type of construction task that is being performed. For example, foundation construction, for example, framing, or bricklaying, drilling, painting, off-site prefabrication, and so on. This picture showed an example robot that is used for demolition applications. It comes from a well-known vendor based in Sweden, but with large operations also in the rest of Europe and North America. The DXR 300 model is a multi-purpose manipulator based on a mobile platform, and it's remotely operated, remotely controlled for the ability of humans to be removed from unhealthy and unsafe, potentially unsafe work site. You can see the characteristics of this robot here. It's rather small. It has a large power to weight ratio. Therefore, it's very useful for a variety of reasons. Ability to move this robot quite easily from one work site to another, and at the same time apply it to a variety of tasks requiring projection of large forces, and in fact performing this work in a fairly unstable environments due to its large and powerful outriggers. This is another example of a robot manipulator that is used to manipulate a steel beam into a position, a particularly important task, especially in confined workspaces, where overhead crane robots may not be very practical in applications. And this particular model has a 750 kilo lifting capacity, which makes it quite practical for a variety of smaller construction jobs. And this manipulator is in fact intended for rather small steel frame building projects. There are also numerically controlled robotics that do not require any significant sensing capabilities. This is a company from Baltimore, Maryland, by the name of Blueprint Robotics. That is active in the area of off-site construction. In fact, fabricating frames and other non-structural and structural components for buildings. They are initially well known for their work in prefabricated, customized wooden elements for various builders, but they're also very quickly moving to composites and steel components, and they are in fact quite successful on the eastern coast of the United States with precise approaches to construct walls, floors, and various elements of roof structures. This is a drawing, a picture that showed a factory floor when some of these elements are being produced. The production capacity of this company is rapidly expanding, and they're also adding window frames as an additional product that they are supplying to various builders in various sizes and various shapes, and able to very quickly retool the production lines to produce different kinds of components for different buildings. And they also intend to expand their business scope in the next decade or so to include commercial buildings and non-building components for other types of structures. This is an example of a robot that is specifically designed and produced to build brick walls. Brick construction, wall construction is particularly important in the developed country construction markets simply because the number of skilled and available bricklayers is rapidly diminishing in the developed world, and therefore a number of companies and a number of parts of the world are looking at the possibility of employing automation. in this realm. And this particular company, Advanced Robotics, is now active in the production of semi-automated Mason robot called SAM 100, and the material unit lift enhancement robot that is also capable of lifting and manipulating into position a number of structural and non-structural components for building sites. So this is a close-up view of this second robot, Mule 135. It's designed for bricklaying workers and retaining wall contractors, and the primary purpose is to ease the strain on the worker from lifting heavy weights in uncomfortable positions. This is the bricklaying robot close-up. This particular model, SAM 100, is capable of laying about 350 bricks per hour and 3,000 bricks per day. In fact, the workday of the robot can be extended almost at will, with the exception that you have to pay attention to the work hours of the human operator, but the robot is capable of performing over extended hours, and in fact, over even a period of 3 work shifts during a workday. So there is also parallel development to design and implement other robotics to increase safety and efficiency in nuclear power plant decommissioning, as there is a large number of aging nuclear power plants throughout North America, Europe, and other parts of the developed world, where robotic performance during decommissioning tasks will indeed be extremely advantageous if compared with traditional means of performing dangerous, possibly dangerous tasks in radioactively contaminated areas. Painting is a mature application in manufacturing plants, of course, especially automotive plants, and it's making inroads also into the construction industry, particularly for spray painting of building surfaces, both interior and exterior. So a number of robotic vendors are interested in that application and making progress in that area. There are a lot of prefabrication companies that are implementing robotics for high-rise building construction as well, stacking up modules to create high-rise building landscapes. There are companies in California as well as in Texas and on the eastern coast of the United States that are also active in that market. So the three-dimensional modules are in fact most productive applications of robotics for these types of projects. In this particular instance, a rather urban company is producing modules as four-sided boxes, and the overall result of that work is that construction cost is cut by 20%, and delivery times of these projects is also reduced by 30%, which makes a significant impact on the total cost of construction and schedule. There is a company that unfortunately recently went out of business, Catera, CLT. This is a cross-laminated timber company that was promoting structural wood as a construction material. And in fact, the company became famous for automating upstream as well as downstream applications, creating a seamless process that would employ a number of semi-automated and fully automated equipment to deliver various components of a building, as well as assembly tasks that would be semi-automated or in some cases fully automated on construction sites. Unfortunately, the company was a bit ahead of its time, and supply chain issues actually caused a demise of the initial attempt to fully automate the delivery process from design to construction and handover to project owner. Nevertheless, in the near future, similar efforts will be resurrected, not just in North America, but elsewhere in the world, to try to automate as much of the supply chain and the delivery process of buildings with the use of industrial robotics, specifically designed for that purpose. Another important application is robotics for overhead power transmission lines. Of course, this work is extremely dangerous if workers are exposed to high voltage lines. There is an imminent danger of electrocution, and robots that are specifically designed for that task are in fact being implemented on a number of utility lines throughout North America and some other parts of the world. A variety of applications are possible in that realm. Robots for underground utility works are becoming very popular in North America, especially for detection of leaks in water pipes, so water lines as well as sewage lines. A number of other applications are possible to reline surfaces of the interiors of pipes without the need to excavate these pipes and wreak havoc in municipal areas with heavy traffic volumes. There is a company by the name of Red Zone Robotics based in Pennsylvania, also initially involved in developing robots for nuclear power plant decommissioning and inspection, but lately focusing almost entirely on the development of robotic applications for underground utility lines. Every large city in North America and in Europe has similar problems with not fully documented location and inventory of these utility lines, so robotic performance is extremely advantageous in that regard. There are a number of different models and applications of these robots underground, and also underwater robotics is another area of development that that particular company is getting into. A number of example applications have been marketed also in various European markets. So, for example, this unmanned sewer inspection robot can compile inspection data in pipes. It performs at relatively high speed, and the cost savings with respect to manual performance of that work is approximately $5 per 1 meter, which makes it a very attractive proposition as an alternative to human performance of this task. Other mature applications that are almost ubiquitous in surveying companies are right now are drone applications to document and map construction sites and map also topography of the terrain where future construction projects will be performed. A number of companies operate in that market. A lot of that technology is direct transfer from military applications, and these robots making inroads into civilian work tasks, civilian industries such as construction are in fact very popular, and there isn't a large and well-established surveying company right now that is not utilizing drones for its mapping tasks, as they are tremendous cost and time savers during the performance of these tasks. So a variety of industries, construction, as well as mining, as well as other industries that rely on outdoor equipment, surveying equipment, can utilize this technology. So also design firms that need to gather topographical data in order to perform their design tasks are also very interested in utilizing these applications. The last application I want to present is the application of heavy lift drones, initially inspired by firefighting needs, but lately being considered also for assembly tasks on high-rise building construction, possibly in the future eliminating the need for tower cranes altogether. Nevertheless, those applications are still in the early stages of development, and stay tuned. There are a number of companies interested in that work. Spin-offs from ETH in Zurich, Switzerland, working together with spin-offs in Singapore, are developing new applications for high-rise building construction, for structures as tall as 75 stories at this point in time, possibly more in the future. And we have to stay tuned and see what develops and what the real market needs will be. So thank you for your attention. And if there are any questions, I will be happy to remotely communicate with you via email. Please contact me through the Łukasiewicz Network Industrial Institute for Automation and Measurement. Thank you very much.
Okay, please give Professor Skibniewski virtual applause. So concerning the questions, please contact me. I will give you my business card, and then you can send questions to Professor Skibniewski by email, and he will answer. So now let me introduce Professor Bocińskas from Vilnius Technical University, who will give his presentation. The floor is yours. 20 minutes.
20 minutes. I will try to be in time. Okay. I want to present another issue of artificial intellect implementation in the robotic and the more widespread as a problem of ontology. In fact, ontology is the well-known philosophical problem which represents the picture of the world. It started so long time ago as the famous Platonian cave image representing our ontology as the world picture. It is delivered by many ways, but nobody knows when and how it is delivered. I mean, we can collect experience, we can collect many things, but we cannot transfer it to another. We can say intellectually, but we cannot transfer our understanding, our experience. From the other point of view, people sitting, for instance, here, have some similarity in their picture of the view, but have the differences, and it is hard to explain. We can speculate different condition, different parent professions, whatever, but we can't explain it in reality. On the other hand, if we want to create a synthetic ontology for the new coming machines, to developing artificial intellect, to developing capability using artificial intellect for the task solution, Sooner or later, we come back to the ontology. So here I want to present shortly history of robots in relation to their existent or non-existent ontology, for direct control, for sensor fusion issues about the sensor fusion as the ontological process, i.e. in robotics shortly, then machine learning issue in ontology and modern achievement and exploitation in future. So I'm trying to structure in the blocks. So if we look for the first humanoid robots, which was created, just was like a dolls or mechanized dolls. I mean, they are ontological, even the sensitive capabilities was minimal. In fact, everybody was happy to having such doll moving, but in fact, their intelligence was on the zero level. This is normal, because at that time, the created doll has another meaning. In 1972, we have the first robot to use artificial intelligence. This interpreting pictures is just more to get fun rather than real representation of artificial intelligence. But as the previous prelegents told, that artificial intelligence, again, it is widespread technologies which can be realized through computers, through computing technology, and therefore artificial intelligent tasks typically is represented now as a few parameters. First is search and found, another compose, and the third to provide the information. So here, the 1978 first pick-and-place car robots with a multiply sensor array was quite famous, and suddenly it was found that simple multiplexity of sensors in the robot cannot solve the intelligence problem. I mean, you can get equipped multiply of sensor, each degrees of freedom has displacement and force sensors, and anyway, the operation have bugs and have the issues which cannot be solved by increasing number of sensors. That means that it's necessary to find another point of view by getting this information into certain way of process. So during the development of robots, as you see, the shape and forms, they are changed from the very primitive to absolutely human-like, or let's say human mimicry robots. But anyway, the shape, which is a big issue of speculation, actually very hardly conforms with their function, except maybe social robots, or let's say medical robots, which plays a role also the human emotion to the robot itself. I can even mention the term of robophobia. I have a recent paper where introduction of robots into industry also limited by natural robophobia of humans who is simply scared to deal with that. Anyway, if you see the line of robotic solution, then actually we all the time have raising point, but still not having a breakthrough in the typically autonomous dealing of robot in changing environment. In here, by the way, one picture, one of the best 1961 walking industrial robot, which was made in in states, and that was the really useful device, indifferent from the human-like dolls, which was a funny, but not so much implemented in the reality. So, of course, the first is direct control. Direct control, it creates a series of manipulators, and direct control, it means that you can record points of trajectory to put sensors, for instance, for force, acceleration, and something, and get the situation which keeps a long time till now. So the robot evolution went into few branches, and at the moment, extensive AI control still remain a kind of something coming in the future. A solution of tasks like pathfinding, like navigation, the same in the car, like fixed solution choice. The best example is ticketing. If you're buying from Warsaw to Newcastle and you just point initial point and end point and you get the tickets, even combining planes, trains, even bike. You can get, so this is tasks capable to use for real state of artificial intelligent systems. It's good or bad? Of course, it's very good. What cannot do such systems, as well as robots? They cannot do one thing. They can generate solution. They can pick solution from existing, but they cannot generate solution. And this is not a limitation of something. This is a nature we cannot bypass, because ontology in such systems actually is not existent. So if we talk about human and robot cooperation, so actually the known few modes like cell, separated, coexistence when robot works their own and human works their own operation. It can be synchronized. When robot puts something, I can take it. It can be cooperation when we deal together, and the best is collaboration when we can even replace certain functionalities. All these modes are by increasing the number, increasing intelligence in robotics. Actually, the last one is available only so-called cobots or intellectual mobile solution if we're talking about mobile robots. Anyway, still, understanding of human mnemonics is set to be in future. I mean, if you have a moving obstacle, standing obstacle, it is solvable easy. But prediction of obstacle movement still is kept in mysterious fog. So such collaborative assembly, that's the reality of many modern designs of the production, and I think it should be sooner be replaced, because in many cases the human participant there is not necessarily to work with hands, only to monitor it. So now I'm going to the ontology itself and try not to torture you with a super philosophical derivation, but anyway. At the moment, all ontology has no, synthetic ontology has no real form. I mean, we don't know how it's organized. For instance, if we have an ontology, point of our view, developed from our childhood to now, we can say that it is important for me, it's not important for me, my behavior is related to history, logics, my senses, everything. But I cannot transfer the tiniest piece of my experience to you. I can tell about it intellectually. I can get you even feeling how was fun or how was scared about something, but I cannot transfer not a single piece of my experience. And in this case, I want to say that even the smallest part of ontology cannot be transferred to robots as well. So we need to create absolutely different ontology for the machines rather than we have in human places. That's not new. Think about sewing machine. If you have a needle, a classical needle, and you make a saw, and you want to using sewing machine, we're using simply different technology. The most funny thing is, why use printer if we have robots? Put a pen for the robot hand, he can write instead of you. So it is not the machinery. So if we do synthetic ontology, that's absolutely different. And what we can do? First, we can create big amount of information coming and try to fuse it. Also, we can try to use a cognitive, to identify each piece of existing situation, identify, here is a human, here is a mouse, here is a obstacle, here is a moving detail. But this path leads us to the deadlock. Why? Because amount of identified objects requires a huge piece of ontology, which is technically not possible, even if you have enormous amounts of calculation. So, what we can do? We can create ontology as a form of object programming. This is a very popular way. We say we have a class of objects, for instance, table tools, forks, knives, spoons. And then we can say, okay, we have a fork we put in the left box, we have a knife we put in the right box, and then we even open the certain possibility to learn. We have forks bigger, smaller, decent forks, we can even tiny forks, but we can say it is a fork. So object-oriented programming as a basis of recent ontology is available, and it is used as a fixed ontology for the smart machines. What's good? It's good that you can easily deal with that because mechanisms are known. What is bad? Limits, because you reach limits very fast. What is self-learning? Self-learning, you can add another object. What is limitation? You cannot do another class by machines because machines not thinking. Machines just are doing the calculation. And calculation, means you follow the path and doing the performance of the cycles. So solution of that, you can say fork, 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 knife, knife, spoon, unknown. And that makes what you can do with such approach. Okay, here I want to present you some of one of our things. It is a channel robot solution, which is used to use very fast insight online calculation to predict the channel form. Here, I would have a laser. Okay, so here you see the projecting 4 lines. It is a laser beams and picture of future on the screen, which can be clarified and extend into the formalized picture, which means we have an obstacle, and this obstacle is bypassable or not. Here is the real place for the experiment, and this was the aluminum piece, was the obstacle for that. And here you have the very thin lines as a result. What it means, you have a single-dimensional array which can say it is bypassable, it is not, it is whole, or it is inside. So this is a ontological processed picture view in channel where you can decide, is it obstacle, is it hole, it is wall. Here it's wrote only the horizontal downstairs. The same situation can be done on the walls, on the top, and then you can find the way to go without having interaction from outside, and you can define a possibility to pass or not. So this performed on very weak processor and not requires any additional resources to deal in that. So the test was quite sophisticated, and you can do the thing, I would say, the navigating and taking solution from very limited amount of data. Sensor fusion. If you have sensor fusion connection of many sensors, there are different levels of them. And here, ontology is one of the first place in AI which is absolutely necessary. For instance, if you have equal sensor, like two distance measurement, even then you need to process them not just as two typical data, but you need to get a situation from that. So sensor fusion is known technology, but good sensor fusion, think about humans. We have 5 senses, and from these 5 senses we can deal in the world, we can do everything. So multiplexity of sensors not necessarily give you full scale of the world. And for autonomous robots, there are a lot of trials to create ontology using tree-like or using neural-like. There are trials to create objects, there are trials to create processes. XML type, ontology, everything that goes to the same situation. You are limited by representation form. So anyway, this is very highly developing area of AI, and how successfully we get into the real world representation, then we get into the high level of AI compatibility and machine learning. Machine learning is the issue which is very popular now in the moment, but looking from the side of ontology, machine learning is giving you very primitive things. They give a parameter for formula, but not more. I mean, you can find the correct timing, you can find the correct coordinates, you can adjust some processes, but do not create new entities at all. So, and to make it short, expectation and future. So what's possible? Creating compact and transferable worldview for machines. Issues to the existing classes of objects. High-level adaptivity and adaptive human-machine interface. It is really coming and possible. What is impossible? It is machine interest, so-called, because machine is just a soulless device which not have any interest or emotions. Self-creating, I mean to create ontology inside. Recursive, self-create strategy, and more issues. So that's what I want to present you. Thank you.
Thank you very much. So, due to the time constraints, we will skip the questions. So maybe you can ask some questions to Professor Bucinskas after our session. So thank you very much again. So now we move to more to the industrial side of robotics. So now Mr. Konrad Kopp will give the presentation, which is I suppose much closer to the real applications. Indeed. So the next two presentations will be of our industrial partners, and we will see the applications of robotics and artificial intelligence in the real world. So 20 minutes, floor is yours.
All right. Hello everyone, and welcome to my presentation. We have heard some theoretical introductions so far, very interesting aspects of fundamental research, but I would like to give you a little bit more insight into practical applications. And in these 20 minutes, I will try to go through something that I call the paradox of simple processes. So in other words, I would try to go together with you through the question why these simple processes are actually very difficult to robotize. So yeah, let's start. My name is Konrad Kopp, and I'm the technical lead at United Robots. So before we move on, I would like to invite all of you to the task and think together about the following. Imagine that you are given this kind of environment, and you are asked to clean the floor in this environment. Now think about it. How would you approach this problem? How would you decide where to go? How would you decide which aisles to clean first? How would you decide on the parameters? And finally, how would you decide on the tools to actually do that? Of course, as we are going through the robotization session, my proposal would be to use a robot to do that. But for the next couple of slides, I would like to go through different aspects and think about why is it actually difficult for the robot to do this task that we consider very simple. At the end of the day, cleaning the floor is something very, very basic. So there is a couple of things that come into the game when we want to robotize this process. The first thing is that the robot has to do the map and localize in the environment. Then it has to optimize the process. So somehow find the most efficient way to clean the given space. Then it has to navigate in this environment. And finally, it has to do the cleaning. So the actual task that we are considering. But as you can see, there is a couple of steps before we actually get to that point. So let's start with the first thing, which is mapping and localization. So for those of you who are not that familiar with robotics, let's jump a little bit into what is a map. And the map is something that you can see in this image. So a representation of the environment obtained by the sensors that the robots have on board. So it could be depth cameras, LiDAR sensors, and this kind of sensors. And the localization is something that the robot must do in real time. Basically, it has to find its position in the map in real time. So all the time knowing where it exactly is, so that it can proceed with its actions, exactly knowing where it is. So this is very important. But as you can see already, this map is quite complex. This is, by the way, a warehouse. But I can tell you from experience, this is quite difficult to localize. And here are the challenges where it actually is coming from. So the first thing that is very difficult in reality is that the environment is very repeatable. By this, we mean that when you enter a warehouse, you see one aisle, another. There's like hundreds of aisles that look exactly the same. If you as a human being are placed in the warehouse, you would have problems finding yourself. I can tell you from experience, this is very difficult when the warehouse is really big. And for robots, it's even more difficult because they are not that advanced. So that's the first problem, that there is repetition in the environment. Another problem that we typically face when deploying the robots in such environments is that they change drastically from day to day. So on one day, as you can see, we have this type of environment, which is a warehouse that has boxes and pallets in the shelves. On the other day, we have shelves that are empty. So from the robot's point of view, that is using specific types of sensors, which I will tell in the next slide, the difference between these two is that on the first image, it sees the wall in the aisle. In the other image, where the shelves are empty, it just doesn't see anything. So there is empty space, and then the robot might delocalize, so might not be sure where it is exactly. So how to tackle this problem? Of course, the AI kicks in when we are considering this. So when we are thinking about the localization challenges, we need to consider first what is the type of representation the robots are using for the navigation. So our robots typically use a 3D point clouds that are obtained by LiDARs or depth cameras. So this is how it looks like pretty much. It's a room scanned with a LiDAR. And now, the thing is that if we want to exclude the influence of these dynamic objects, we need to somehow be able to discard the irrelevant data. So how to say that the boxes that we are looking at, we should not take into account during the localization processes. And this is where the AI kicks in. So what you could do is, for example, you can solve the task of semantic segmentation. This task is about finding out specific clusters in the point cloud and saying that this cluster is a car and another cluster is human, pallet, and so on. So this is what we do. What you see in the image is the blue points are showing the background and the red points are showing classes of interest. So if you are able to say these points belong to the class pallet, car, and so on, you can take it out and then have just the background information that can be used for the localization. So this is the way you could deal with that, but there are other challenges. One of the important things is for the robot to know where it starts. We call it a robot's wake-up problem. So when you turn on the robot, it might not know where exactly it is. If it stopped in the previous position and then you start exactly in the same place, then it's fine. But if you turned it off and moved it elsewhere, then it might have problems to find out where it is. And then these problems of finding initial position kicks in, which is basically finding out where is the place of interest, so this small picture on the bottom right, in the context of the whole map. This is a very complex problem when we have big maps that the search space is very big. The other localization challenge is coming from different types of environments, or actually the size of the environments. What you see in the image are two different maps that we generated during the deployment of our robot. So the top map is coming from a shopping mall, one floor of a shopping mall. That's why you see these fancy shapes. The bottom one comes from the warehouse, a very big warehouse in Poland. Now, the difference between these two maps in terms of areas is like the top one is around 10,000 square meters, the bottom one is 40,000 square meters. So the bottom one is much bigger, but the thing is that in terms of resource consumption, the bottom one requires much more resources than the top one. And this is one of the challenges that we are facing when deploying the robots in reality, that you have a very limited resources. There is a question from the audience. That wasn't that difficult, I must say. The question was about the auditorium maximum. It's not that big, to be honest. So it took us, there is Jakub over there. How much time did it take you? 5 minutes. So that was quite an easy one. I can tell you that the bottom one that we are seeing over here, it took us around 4 hours, 5 hours, something like that, right? Yes. So the comparison is quite different. But the thing is that you really need a lot of resources to deploy the robot in vast spaces, especially if they are open spaces like the warehouse. It requires a lot of resources. And when you are running the algorithms on the edge, so on the robot, then it's very difficult to actually provide that much resources unless you want to drain the battery very quickly. So this is quite a challenge. We're facing practical applications. The algorithms are there, how to do this, but you need to have enough resources, and that's not that obvious when you're using the robots. Okay, so let's move to the next task, which is optimization of the process. So let's get back to the task and think about this location. So we have the warehouse. This is how it looks like when you enter it. But when you do the map, we already know how to do this. It looks more or less like this. So that's another example of a warehouse where we deployed our robot. And as you can see, this is already quite a complex shape. So there is a lot of aisles, perpendicular, parallel, and a lot of different spaces of different shapes. So planning the process in this kind of environment is not that obvious, because how exactly would you set up the paths in this environment? It's not that easy. And when you want to deploy the robot, you of course want to do it in the automatic way. So what we developed is something, do I have a cursor here? Yeah, seems like. Yes, so what we developed here is the way to actually automatically find out the coverage zones in the environment that would fit in exactly in the map that we are seeing over here. So what this algorithm is doing, it actually fits the set of rectangles in the map, and then thanks to that, it generates the zones in which the robot would clean the space. Now, there is the assumption that we actually have proven empirically in different environments that when we have a structured environment, that is man-made environment, the surroundings can be expressed as a set of rectangles. And we actually do that in this way, that we can approximate the environment in that way. So we have the zones and the paths within the zones, but then the next step of optimizing the process is actually finding the sequence. So the next step is this. You have a map, you have zones in this map, and as you can see, this is a different one. The zones are already much more complex. So first of all, fitting the path in this one is quite a challenge, but then you have to optimize the sequence. To do so, you have a couple of different elements that you need to take into account. There is 3 main building blocks of building up a sequence. The first one is the zones. So if you extract those, they might look like that. So you have this set of zones. Then you need to take into account docking stations. So these are the points in the map where the robot has to go to refill its resources. So either refill the water, release dirty water, and so on. And then there is the third aspect, which is having traversal trajectories, so that the ways, the trajectories between different zones and between the docking stations. And these 3 you need to take into account when creating the sequence. So for those of you who are working with algorithms, that already pretty much sums up to a traveling salesman problem. There is plenty of solutions to that, from classical approaches to reinforcement learning. We are actually using an evolutionary algorithm for that. But yeah, this is a complex problem when we have a lot of zones to take into account. Okay, so we have a map, we have the zones and sequence planned, so we have to actually navigate in this environment. So again, for those of you who are not into robotics, a short explanation, what is robotic navigation? So the first thing is the global planning. So you need the robot, maybe we can mute the sound from the video. Or I can do that maybe. So what you see, the global path planning is the process of finding the best trajectory, the optimal trajectory from one place to another. That's the global planning. And then there is another step, which is local obstacle avoidance. Sorry about that. So this is the robot acting in another environment, and it has to find a way and avoid the obstacles in this very complex environment. So as you can see, it's very tight, it's very dynamic, and it has to find a way. So this is the robotic navigation. So where is actually the challenge? Because these algorithms are already developed and well known. So here is the challenge. When you go for the deployment, once again, I'm coming back to the picture, the warehouse looks like this. Very empty, neat, structured, path plan, everything is perfect. So great environment to deploy the robot. So you leave the robot, you give the keys to the customer, and then you go happily back home. And then the next day, this happens. So everything is fully crowded with objects, pallets, boxes, and so on. And then the robot is not able to actually navigate efficiently in this environment. So this is another example from the actual application. When the planning was there and mapping was there, the environment was clear and empty. And then during the deployment, you see there is a lot of, during the operation, there is a lot of pallets, boxes, and so on. So we are actually facing this problem in pretty much every environment where we deploy our robots. And we need to somehow tackle this problem. Now, we asked ourselves this question. Can we actually predict, based on partial view of the obstacle, how much it would occupy on the floor in this specific space. So in other words, when you consider an obstacle standing in front of the robot, this is a very synthetic view of that. The robot sees the obstacle, but the sensors actually see the front wall of the obstacle. There is, of course, something behind it, and we as humans know it, but the robot doesn't know it if it doesn't learn. So if it's asked to plan the path when standing in this position, it could potentially go behind the box and try to reach the area behind the box, because it doesn't have this information, unless we learn it. And then this is exactly what we developed for tackling this problem. So we developed the algorithm to actually predict the footprint of obstacles that can appear in the specific environment. So what you see on this image on the right, the red points, the red dots are the points in the point cloud that the robot actually sees. And as you can see, these are partial views only of the obstacle. So what we do is we take these partial views and predict the footprint of the obstacles. In this case, this is a parking scenario. So the robot manages to predict these are the cars and directly blacklist the areas it should not clean, by that increasing a lot the efficiency of the process. So that can be solved in this way. And then we are coming to the last challenge, which was actually our basic task, which is the cleaning. So first of all, when you think about the cleaning, you might think about this, so a bucket and a mop. This is obviously not the way we do it with the robots, but for those of you who are not familiar with the automized process of cleaning, this is what happens. So first of all, the robot has brushes in front of it, which distribute the water and scrub the floor to remove the dirt. Then we have a squeegee that is made of rubber, and this squeegee is removing the water and the dirt from the floor. Then we have pipes that take the water up to the dirty water container using vacuum pump. And finally, on top of the container, we have a dirt filter that prevents from solid pieces of dirt to get into the container. So this is pretty much how it works. But then there is a lot of mechanical interactions between the robot and the environment, so there might be some issues happening. So the first one is that something can get clogged in the water circulation system. For example, in the squeegee or in the pipe or in the filter, something can get stuck, or the dirt can accumulate and block the normal flow of the water. If this happens, then the water is not sucked properly, it's left on the floor, and then everything is dirty. So the quality of the process drops significantly. So you could solve it in many ways. For example, you could attach some pressure sensors in the system. But first of all, they're expensive. And secondly, you need to modify the whole setup to actually build them up. And thirdly, when you put them in the pipe, this actually creates their own blockage of the pipe. So this is not the best solution. But of course, again, the AI kicks in. And what we are doing over here is based on vibration analysis or acceleration analysis or gyro analysis, using either Fourier analysis, or we are actually also using deep neural network to detect anomalies in the system. So based on just the accelerometers that you anyways have in the robot, we can say, okay, this pipe is clogged or will be clogged in half an hour considering this environment. So this is already possible without any extra hardware. So to wrap up, we've went to the process and different steps to actually robotize the process of cleaning. And as you can see, and I hope you now understand that this is not so easy to robotize this process, because there is a couple of challenges. So the first one is, in terms of mapping, we have repeatable and dynamic environment, and the maps are very large, which is very problematic for devices with limited resources. Then when we have to optimize the process, we have irregular shapes of the zones, and the optimization problem itself is very complex. Then when considering the navigation, we have dynamic obstacles. And when we are doing the cleaning, there is non-obvious issues, symptoms, that something is happening in a wrong way. So we are working on that for a couple of years already. And as you might be surprised or not, a solution for that would be the cleaner. And if you want to see it in reality, please visit us in the other building, in the exhibition hall, where we can tell you everything about this, because this is actually our child. Thanks a lot for your attention, and I'm happy to answer any question.
Thank you. So maybe instead of the question, just a short comment that it was the real eye-opener. So just a simple task, clean the floor, and so many issues and so many artificial intelligence and robotics techniques applied. So it was really something very interesting. The real application can be complicated. Thank you very much.
Thank you very much.
So now we move to the last presentation. This will come from Vasco and COIG companies. So Mr. Marek Ujejski will be presenter. Also the other author is Marek Woszczyna, who is here with us? No. Okay.
No, I have to explain. Marek Woszczyna was unable to come to our meeting, and he is in other activities. Please take my apologize for it.
Yeah, of course. You don't have to apologize. At least you can give the presentation. Yeah. So it will be about automatization of your ideas. So the floor is yours.
Thank you very much. May I turn my microphone? It will be much easier. Ladies and gentlemen, this is a short presentation, almost 10 minutes in my time frame already passed, but I try to explain very detailed what is possible in the time. And for us, what is NetApps? NetApps is a software product which allows to automate simple administration tasks and more sophisticated tasks related to security, to verify how infrastructure is constructed, how to take some information from this infrastructure, how to take information about vulnerabilities, and how to generate automatically way some reports for administrator, for high-level staff, and also for authorities, because as you know, European regulation NIS2 is coming, and Poland is already trying to implement a bill which is still under preparation in the parliament, but more or later some bill will be issued by our parliament. Let's allow me to start from a short video which presents some idea in a very fast way. Maybe I start the video. It's too loudly? Too loudly? I don't know. Oh, just a moment. That is a video. Should start again. I don't know why it's not starting. This, probably video was not delivered to organizer, but I don't know. It's only on the first page of video. If it's not starting, I try to push maybe this way. Also, it's not working. Maybe this way. No, video is not working. Okay. That was fault done by somebody, I don't know. But I trying to explain remaining part. It will be almost the same, because video is rather on marketing, from marketing side is very fast and not presenting some idea which are behind. The first of all, what is NetApps system? NetApps system is, as is written on the screen, is some reliable tools which allow administrator to automate work, and based on some standardization which was in assumption, allowing us to connect different software solution and integrate everything together to start this administration and security work more smoothly. Of course, all this activity requires some orchestration. It's also implemented in the system. Finally, we decided to start some works with artificial intelligence, but this work currently under progress, that I can tell you that is fully in a robust way, but artificial intelligence is on the beginning stage. Let's move to the next slide. That is an area which system could be used. As I said, it's a lot of companies, a lot of sector which we can use such solution. Primarily, we started from telco company. We delivered first implementation to telco. Of course, after some, let's say, internal works, the COIG was a company which started some, let's say, pre-production tests, because we are operated as a security operators, and we deliver utils like security operation center, and parallel to professional tools, we use this NetApps to verify results. Because I don't mention till now, NetApps is based on open source, mainly on open source, but if somebody looks for some commercial solution, it could be attached as well. The main work which is on the beginning is inventory. If you are going to take some information about your infrastructure, you have to start from taking information about asset. Inventory is, let's say, maybe it's not so complicated, but it's a very long process because sometimes it's 100,000 devices in your network. It's difficult to achieve information what in fact in given point of time is already working on your system. The same is for some development work. If somebody trying to prepare a new application, you have to test it if it's reasonable, resistant against some threats, and these tools also allow you to take information how your application is resistant against vulnerabilities and against dangers coming from outside based on already described vulnerabilities. And maybe it's one solution for everything. This statement was done by marketing department. They trying to improve our presentation, but of course, it's one solution for everything does not exist. Of course, I rather said that is a Swiss knife for administrative and security work. Due to lack of time, I'm not going to exactly explain what's going on, how it's constructed, but we pass on the latest slide about some internal construction. The main process is, as I said, automation of work which should be done under your infrastructure. You have to take some analysis, you have to take 1 billion of logs, and of course you have to produce some reports about your environment. Everything should be presented also in graphical form because it's very difficult to manage 1,000 or million or billions digit because that is not possible to manage by human such information. Much more interesting for administrator, for managers and for other authorities is to taking information based on visual presentation, and therefore graphical modeling process is also implemented in the system. It's a short few slides about functionality. However, it's difficult to see because the letters are very small. I only tell you what is the process. The process, sorry, I pushed too fast. The process is about taking information about inventory. We're starting from the first slide. Everything is done automatically. The next slide is example for telco communications, let's say more sophisticated kind of enterprises. And finally, we starting information about one given devices. Juniper is a Juniper, doesn't matter how you pronounce. It's a devices for network. And you have to take some information how this devices is configured, and based on information which is stored inside the devices, you can take all necessary information for your future process. On the beginning, you have to take some authentication token, which is presented on this line. Just a moment. This is taking authentication token. This is UR, which under this UR, all this information is stored. You can take out this information, and having this authentication token, you can start taking other information stored in given devices. And finally, all information also invisible, everything is almost black, sorry for that. Information is presented in graphical form on the screen, on the top of the screen, and you take some information, very synthetic way, how this Juniper devices is configured. This is a presentation on the last screen, this one, how you define all work which should be automated. This is a boxes, and boxes are ready to use, but if you need some other kind of boxes, you can develop on self, or you can ask our company about preparing contents of these boxes, and after them you can easily connect box to another box, making a pipeline which allow you to take required functionality. This is a short example which kind of protocol are already implemented. As I said, the main assumption was to use only well-known protocols, therefore SNMP version 1, 2, 3 is also supported. This is the main protocol which allow you to take information from typical hosts, from typical devices. Also REST or RESTconf is also available for some kind of web application. Also, because the application was formally prepared for telecommunication sector, maybe not so popular, but old one, TL1 protocol for telecom is also available on this configuration. And other protocols like SSG, which allow you to manage remote devices, even Telnet, which is a very old protocol, not secure, of course, but a lot of network devices are managed by them. You are looking for oh, sorry, but I'm trying to fasten my presentation as well. And of course, typical SQL and NoSQL query is available in current implementation. How we are doing with the NetApps? First of all, we can start our operation using a manual stream. We can take some activity through the REST application. If you need some, let's say, activity started step by step, you can use batch mode, and if some activity should start on given point of time, you can use schedule. For example, if you're trying to make cyclically if you're trying to take cyclically some information about vulnerabilities, it's impossible to start such activity in normal work hour, because this makes some difficulties for user, and therefore such activity should be run outside normal hours. And for that time schedule is also available. You can start all activity after work hours. And all this information could be presented on the screen, as it's not moving ahead, but I think so that is a result of PDF presentation. Somebody forget about PowerPoint format. All this information is presented in graphical form. If you, most of this screen are already prepared, but if you need some other presentation based on statistics coming from this information stored in the database, you can use your own definition, and using Elasticsearch and Kibana, you can present all this information as well, based on your specific needs. And now if, let's say, highest point of our presentation, it would be some security case which explain more exactly how it's working. Because it's PDF, I cannot make some animation, but I try to explain what's going on. On the beginning, you have some IT infrastructure, which collects some assets. Assets mean hardware devices, software devices, network devices, everything which is called as an asset. And from the second point of view, you have this pure administrator or security guy which is responsible for making day-by-day activity and collecting all the information. On the beginning, I have to explain that most of our environment is based on virtual environment. Practically almost all typical virtual environment are available. For example, typical VMware, Hyper-V, Oracle, VLM, OpenStack, and so on. And to start some investigation about let's say IT inventory, because you know, every day your IT inventory is changing, because somebody add another devices, remove another devices, and picture almost in all hours is changing very fastly. Therefore, you have to use some discovery tools on the beginning. It's well known, open source Nmap. It's a very robust and very effective tools, which I use as very effective for several years. Of course, you can use another tools, but it's fundamental to recognize what is inside your environments. And all this information could be stored through the CMD built in asset database. And in next step, if you are going to recognize, let's say, security of your components, you have to start some vulnerability scanner. That is also some open source vulnerability scanners. Nmap is also presented somewhere here. However, Nmap is not a typical discovery tools, vulnerability scanner, sorry. It's rather discovery tools, but also some information coming from Nmap allow you to take some information about vulnerability, because information about protocols, about key are also presented on final report. But if you have 1,000 devices, it's a lot of information, and it is a very ineffective work for human, and therefore all this process should be automated, and our tools allow to take this information, store everything in database, in the central database. And of course, if something will happen in your environment, some information about incidents are stored as well, using this CM, which is currently attached to the system. The components, it's a Vazuch, maybe you have heard about. It's an open source, very effective CM, which is most important, costing nothing as an open source. As you probably know, most of commercial solution, I'm not going to give you some big name companies, because for obvious reason, but a lot of solutions very well working are very costly, and small company and public sector is unable to pay for it, but is obliged due to needs to predict everything what is happening in your environment. This solution allow you very effective way achieve a final result and to be in line in low regulation. If some incident will happen, information from Vazuch is also stored in incident register, and finally could be presented to government authority, to CESIRT. In Polish case, it's a CESIRT government or CESIRT NASK. Other CESIRT related to military forces, but I presented only two, because most of company reported to both CESIRTs. And if you are going to make some proven, if you already discovered vulnerability really exists, you can use also automation pen test, which is more sophisticated, because as you know, it's a very risky process. If you started some payload could be dangerous for system, could fall down your system, and therefore this process should be fully controlled. And automation pen test use also open source solution, Metasploit, also very effective and robust solution, and all this result could be stored this way to common database. And of course, all graphical reports are available. Sorry for lack of animations, which make this process more difficult, but I hope you understand very well how system is constructed and what is achievable using the system. And currently we are working on artificial intelligence assistant. Some of work was already done, but is still under test phases. And what is maybe also important, I have to say that from practical point of view, we as a Zoik is an old company, which probably you have known, is a company which formerly was responsible for computation for Polish mine engineering. Now we removed to other activity as well. And we tested and compared results, these tools with commercial solution, and we can make some observation based on that. We inform our colleague in Vasco if some process needs improvement or not. That is a main information which I'm going to present to you, and is finally that is information about where we are. Big names, T-Mobile, Netia, NASK Of course, Vasco and Zoik as an author and entrepreneur for this solution, other big company like Animex, Astanet was our first customer, and you can take some information, this company, how product looks like and how it's working. And finally, this is information which was missing on the title slide, information about contact point. If you are interested in taking some information about this product, please contact us. Thank you for your patience. Thank you very much. Thank you.
Thank you very much for the very fast presentation, very fast speaking. So as I was expecting, scientists are hard to control, but industrial society is trying to keep in schedule. So very interesting presentations. We moved to the very practical applications, and we can see that from scientists' points of view, maybe simple tasks can be quite complicated and very hard for real-world applications. So thank you very much for all presentations. We conclude the first part of our session, and then we move to another. So with me is Paulina Zielińska, who will introduce our panelists for the second part of the session.
Hello, everybody, and now, as the director said, we are invite you to the second part of our event, organized by the 3 of the 7 industrial contact points. It will be ICP Industry 4.0, ICP Medical Technologies and Health, and also ICP Digital Transformation. We will begin with the panel conversation. How can we build on the experience of the Central and Eastern Europe in Horizon Europe? Moderated by Donata Kałużna from Łukasiewicz-Pitts, ICP Point Digital Transformation. Donata.
Thank you, Paulina. Good morning. After a session full of very interesting and inspiring speeches, it is time for an equally interesting session, but the panel session this time. And why, thank you, why will be like that? Their experience in using the Horizon program and EU funds in general will share with you. Ms. Agnieszka Bachusz, she's the Department of Ownership, Supervision and Economy Marshal Office based here in Krakow. Yes, please. Mr. Jacek Kasz, the Director of the Technology Transfer Center at the Krakow University of Technology. Mr. Krzysztof Samp, the Vice President of ITTI. Ms. Raluca Madalena Lucat, our guest from Romania. She's the IET Manufacturing. And our last guest, Gintras Vildas. He's the Chief Executive Officer for Manufacturing Innovation Valley from Lithuania. And during this 90 minutes, our kind guests, our kind panelists will try to answer the question, how can we build on the experience of the Central and Eastern Europe in European programs? My name is Donata Kałużna. I'm representing the Industry Contact Points Digital Transformation based in Poznań, and I have the pleasure to moderate this panel for you. Before we start, may I ask the gentleman from the technical side to move the table with water in front of our panelists. Would be easier for them to use the water. Yes. I appreciate that. Thank you. Thank you. So let's start our conversation. Digital transformation and innovation are now crucial for the global competitiveness, impacting all regions, especially businesses needed to adapt. And developing nations like here ours in Central and Eastern Europe face greater challenges due to lower economic capacity. They are also the largest beneficiaries of EU funds. And in fact, EU funds have been vital for our countries in recent years in terms of funding public investments and boosting growth. And my question is to you, would you like to ask to our audience about your experience? How did your journey with the programs, European programs framework begin? And I will not point to a specific person, just I'm asking the open question, so please feel free.
Ladies, you can start.
Hello, thank you for having me here today. My journey started 15 years ago when I started to work for regional government, and my first task was to organize study visit to Rhône-Alpes, and it was first experience that shows me how important it is to build connections, to meet people and to work together. And now, after this 15 years, we are in a program for regions called Regional Innovation Valleys. So I think it was a long journey and it will not stop.
Good morning, my name is Jacek Kasz, and I'm running the Center for Technology Transfer of the Politechnika Krakowska, which is Kraków University of Technology. And this is the second oldest CTT, as we call it in Poland, established in '97. And at that time, we started organizing and running and managing the project from the so-called FARE, if you remember. You are still old enough to remember, right? Mid-90s. So since then, we've been doing this for over 25 years. I joined this organization 6 years ago. Moreover, within my unit, there is a horizontal center point for contact point for Horizon programs. So we have a separate team within my group, which is advising, facilitating, consulting, and helping the scientists and the universities in southeastern Poland, in the voivodeships of Kraków, Rzeszów, and Kielce. So this is our daily job since, you may say, '97. Thank you.
Okay. Yes. Okay. So I'm also very glad to be here, and also I believe it's very good to share different experiences, and it gives us a lot of synergy. So our journey also started quite long ago. I also remember FARE program where we worked for Ministry of Finance at that time. But coming to, for instance, framework programs, we started in the year 2001. It was at the time when Poland was still before the accession to EU, and there was such a special program for the new countries to enter ongoing projects. So at that time it was, I would say, quite specific in Poland in particular, for companies to apply for R&D funding. There was such body called KBN in Polish, National Committee for Science. But if we went to them, they said, but are you research? No, we are a company, so we cannot give you any funding. Now we are used to it, to go for different funding for the companies, but at that time it was really, really rare. So this is when we started, it was at the framework program number 5. Originally we used, let's say, some contacts that we have, because in the company at that time we were doing telecom consulting, and then we started in the first projects and then go forward with support of, let's say, different organizations like national contact point, also regional contact points. So it's let's say, quite long journey. I will also share it a bit later on during the presentation.
Thank you.
Hello, everyone. I am Raluca Lucuț. I come from Iceberg Plus, which is a company in Romania. We have experience, more than 14 years experience in mostly writing and implementing projects. What we are doing as well in the country is actually to represent EIT manufacturing. So this is why EIT manufacturing is there on the agenda. We are representing EIT, multiple EIT communities, and our base and core experience is on writing EU projects. So national, both from the European Commission, meaning EIT Manufacturing, Horizon, DG Regio, you name it. Yes, at the beginning, so I'm with Iceberg Plus since 2017, so I already have 7 years. In the beginning, I know that the company started writing projects mainly on the local and regional funding, and after that we moved to the European ones. We try to expand our horizons, let's say, and yes, this is our main. Right now we are splitting into writing project for our own and for our customers, but mainly we focus to go abroad, to expand our community and partnerships. And I think we can discuss more about this and what we encountered on the road. Thank you.
Yes, definitely. Thank you.
Hello, everyone. I'm Gintaras Vilda from Manufacturing Innovation Valley in Lithuania, capital city Vilnius of the country. And we as Manufacturing Innovation Valley, we provide services normally provided by digital innovation hubs. But as a digital innovation hub, we also provide innovation support and consultancy services. We do incubating of the companies, we accelerate in sometimes. And my story was started in 2013 when I was selected as Director of Engineering and Technology Industry Association Lithuania. And there actually we decided that we will work on the 4 directions. One will be to increase number of talents in the engineering and technology industry. Second one, we will help companies and academia to cooperate in the UI activities and to participate in the European networking and Horizon 2020, that time projects. So it was quite interesting story. I would say that when we start, we don't know anything about the programs. You know, it was quite challenging to understand the rules of game. What does it mean partnership? What does it mean program? What does it mean consortia? And especially it was confusing when you arrive to the Brussels, for example, and meet people, meet community, and they're asking you where are you from, what are you doing, and you understand that there is a local community with local rules of game. They spend a lot of time, they know each other, they do a lot of projects, and for us it was the first steps to understand who is who, how they work, what kind of project do they have, and what kind of value we can provide with our members of the association. Yeah.
Thank you very much for your answers. That was very interesting. But now I'm very curious, what were the main challenges you faced in accessing the European program? Maybe Mr. Sam, because you've mentioned already about that shock in combining or cooperating between the science and the business one. So maybe let's start from you, Mr. Sam. From the ITI? Yeah.
Okay, sorry. Yeah, so the challenges were, they were quite similar what was just presented, that to understand first the rules and understand who is who, how the whole program works, and what are the objectives of a particular project, and in part also to be aware that these projects are at the, let's say, lowest TRL level, technology readiness level, so that the effect of the project is not so tangible. And so you need to think about it in much more longer term. So this is, I think, quite important to understand, and in the beginning, that what you can expect from this kind of projects, that this is mainly for building knowledge, building partnership, also, let's say, better understand the whole environment, and also learn new trends. So this is, I think, the one of the main challenges. Of course, we had very basic challenges. At that time, it was, for instance, traveling. The costs of traveling at that time, there was no cheap flights. So, for instance, it was quite expensive to travel. So for an SME, always when we planned to go somewhere in Europe, we did it very carefully, and let's say how to arrange it, maybe travel by car, maybe by night train, or just if fly, then stay over the weekend because it's cheaper, etc. So these are, say, combination of different aspects. So it's, I think, these challenges. And the one more that I would like to stress that appeared at that time, and I think it's still very I would say up to date, is the collaboration with as we work a lot in the security sectors, public security, is the collaboration with end users. It's how to persuade end users to contribute to these projects. And this is what we had at that time in the past, and is still coming. It's not only our Polish problem, but I think it's all around Europe, and how to involve them, how to also show what are the benefits for it. So it's shortly about our challenges.
Thank you. So it's all about the Europe. Maybe you, Rakula, could you please tell us a little bit more from your perspective, the challenges?
I think in the beginning, the challenge going at the European level was actually because in Horizon, you have to have experience in being a partner in different projects and then be the leader of a project. So this was actually, I wouldn't say a challenge, but something to do, and it took years to be involved in multiple Horizon projects as a partner, to gain the confidence and the trust of different partners around Europe, and after that to make yourself known enough to write projects and to coordinate a consortia. So I think that was a challenge, something like that. And travel as well. So right now we are traveling, a lot of us are traveling, as myself, but for many years only our CEO was traveling. And he was doing everything, pitching, selling, and so on, and coming home, and every single one of us started working. So yes, thank you.
Okay, thank you. What the impact has the participation of these European projects from your perspective, your organizations? Yeah.
I can start, actually.
Yes, please.
I would say that when we're talking about the impact, so from our perspective, the main impact was done on the competitiveness of our companies. Because the competitiveness, and especially in manufacturing industry, is essential. Because we act globally, we play globally, and our products normally will sell everywhere in the worldwide. So the competitiveness, to have the products which could be presented as a front-runner products, it's essential for our companies. So by doing our daily activities as Valley, as an association before, we seek for the synergy with such players as Monofuture Technology Platform, as by the way, AT Manufacturing, yeah, and European Factories of the Future Association. So we start working with those partnerships in order to understand the rules, to provide value, to get the access to products, to knowledges, to competences, and it actually help us grow together with the community where you participate. It's not fast, it takes time, because many of European projects, they take 3-4 years and consume a lot of time, but nevertheless, it's important to do and to be the part of that.
So now let's go back to Mr.
I would like to look at this from two perspectives. One is a perspective of my university and also from the contact point perspective. So let's start from the big perspective, and this is, first of all, internationalization is absolutely necessary for us to develop and to stay on the same page with the world, I would say. And we are almost here in family, meaning most of us are Polish, so we know that the best Polish universities are ranked 300, 400, 500. University of Warsaw and Jagiellonian University. So this is not good, and that should, of course, improve. So what is the impact of the project? It's simply, you know, we joined the family, as we said. We are doing the research at the same level of our Western or more developed partners in the past. Now, in some areas, we are better developed than our partners. And also, the overall quality of our research and science has increased. And if we talk about success of the projects and projects applications, this is about research excellence. This is about research excellence, nothing else. And I believe this contributed to our better success rate. Now, from the bigger perspective, then speaking about success rate, we need to understand that Poland as a country contributes around 3% to the overall EU budget. And we only consume roughly 1.5, 1.6% in the forms of the Horizon programs or other programs. So statistically, 1.4, maybe around 1.5% of our contribution goes away. So we, as we sit here, we finance the French, German, Italian, Spanish science. Isn't it paradox? That's kind of crazy that we cannot consume the contribution that we put into the European Union. That this is our main task. So in order to do that, we need to first have more applications, and second, have more applications, and third, we have more applications of high quality. Otherwise, nothing will happen, and we'll still pay to support French researchers, Dutch researchers, and Belgian researchers. And we thought it was opposite. It's not. Thank you. No?
Thank you. Anyone would like to add something to this section or part? No. Okay, thank you. So, what is the real meaning of these organizations here in Central and Eastern Europe for the Horizon program? I mean, what value can organizations from the Central and Eastern Europe bring to projects, consortia like this? I'm also putting an open question.
I'm going to say very quickly because I just spoke too long. But first of all, we are the spice that is given or added to the overall consortium. Secondly, due to political reasons, you know, these consortia shall be designed in the geographical ways and structural ways. So we need north and south, we need west and east. So most often the east is missing, so we're filling this gap. You know, we need somebody from Bulgaria or from Poland or from some, you know, in order to compose the consortium. On the serious note, this previous one was serious too, but we also are the good addition to the different projects or different designs, maybe mechanisms, like Hop-on. And Hop-on is a very good mechanism that allows Central European universities and businesses to jump on existing consortia developed somewhere else. And these organizations need to stem from the Eastern and Central Europe, widening countries. Altogether, Central Europe is needed because it simply completes the consortium. That's my view.
I would say this is a really practical point of view, but if we will look from the bad view, from the perspective of EU, I would say that the participation of the Central and Eastern Europe partners in consortia could give quite or much more broader perspective, because we can give access actually to the market, which is almost 2.6 trillion of US dollars. And actually we also can give access to the community of 250 million of citizens. And if we will take a look from the perspective of academia, we also can give an access to almost half of research community of Europe. And this is so powerful for the Europe. And for example, from the perspective of the cohesion, we also can give access for the European Union to those people who can influence the cohesion of between Central and Eastern Europe, and to help to deploy the innovative solutions developed during the projects into the Eastern European regions. So that's, I think, also really important to note during the negotiation with the European Commission and the member states.
Thank you. Ms. Bachos, we wanted to add something.
I would only add two words. From a regional point of view, what we are doing is simply selling people from our region, people with ideas, people who are very creative, people who are great scientists, and this is the value we can put on the table, let's say. So just as an add from me.
If I can go on this, definitely this is what we can bring, the people and the scientists, engineers, and also well-motivated people, because I think we really bring people who want to contribute and also give sometimes different perspective. This is what I think was already somehow stressed, but I would like to put it more emphasis on it. And I think we definitely see it because we are an SME, so we don't have an ambition to lead big projects, but more and more often we are offered to become a coordinator, because we are well seen as either as a company or as a country to be the leader of different initiatives. So I think this change is significant in the recent years, and this is definitely something that we can bring to this, and we should take this responsibility. We shouldn't be too shy, I would say. This was also, I think, stressed yesterday during one of the panels in the afternoon, that we somehow underestimate our value, and I think we should keep on, let's say, just being self-confident of our value. And quite often, for instance, I've heard when we organized meetings in Poznań, where we are based in, oh, I didn't realize we are such a nice country.
And that would be it. The more courage for us as citizens of these countries here in Central and Eastern Europe, right? So if we are so creative, we've got ambitious businesses, we've got brilliant scientists, and that's all. So there is nothing more to improve.
There is one, but I'm just ashamed to talk about it. This gap is closing, and this is salaries. So the same project or same, let's say, piece of research done in Poland would have been 3 times cheaper than in Germany. That was also the factor. This gap is closing, as I said. So in the next years, it's going to be irrelevant, but it was a factor in the past as well.
And how big is that gap? 20%?
I don't know.
Okay.
They will not tell me.
Sometimes it's opposite almost.
Okay.
I noticed this during the consortium negotiations and things like that, that the Western European universities and companies were willing to put the research here in our country or other countries as well. Is it right, Raluca?
Yes, and what we notice, as you might know, I'm a bit cold, of course, you can notice, the absorption of EU funds, as you mentioned, is really low. So we all need to understand that we need to apply, those are the money, and the money are for us. And we need to apply to those funds. I think it's a lack of confidence as well, as we are presenting in networking events when we are going to Brussels and we are standing in a corner. We just have to put ourselves there and to network and to apply for EU funds and to get the money and to improve our innovation scoreboard, to improve our projects and our ideas and to help the SMEs and startups and so on and so forth. Yes, so the conclusion is apply for that funding.
With good quality applications. And to your point, what was your point? That we are shy. That's right. We are shy, sometimes unnecessarily shy, but also, how shall I put it? There are areas, there are spots in which we can really compete. No, though, I had something on my mind when you were talking and I just lost it, you know?
EU funds.
Oh, EU funds.
Yes.
Yeah. My point was that shyness is one thing, and that results in less scientists or maybe companies too applying because they think it's too difficult. The success rate is very low. It's a lot of work with application for nothing, and so on. And there is also this perception, at least it's been in our country, that, you know, we have a lot of Polish funding as well. So the Polish funding has a perception of being, compared to European, it's easier to get, harder to report. And European funds are harder to get, easier to report, right? Same in Lithuania, I guess.
Exactly. I totally agree with you.
Thank you. Mr. Kash mentioned the government support, that the government support or local government support is needed. So I've got a question to Director Bachusz. What steps can be taken at the regional or national level to strengthen collaboration between Central and Eastern Europe regions and partners from the Western Union?
What can be taken? It is what we are doing. So it is the question: what Małopolska region doing to take the opportunity to be in Horizon Europe? It is a story in different areas. First area is that we, as a region, are in the strong networks. For example, it is a Vanguard Initiative, it is Nereus, it is ERIN, which you already, I suppose, know. So our task, the regional government can support the entities just being in the networks and asking to join to the networks and to build projects in the networks. And it happens. For example, in Vanguard Initiative, we are a coordinator hydrogen pilot project, and we receive funding for just building consortia, so we are in process. And the second area is building, preparing with the scientists, with our partners, technology roadmaps for university, for business, just to show which way we in our region can go to achieve a critical point and to go further. So we do it now in hydrogen, in transportation and storage, and in life science it is healthy food and anti-aging cosmetics. But we have planned to do it in other areas. Another task as a region, we feel that we have to promote our region to promote our region as a strong partner, to build trust, to build networks, to build collaboration, just to at the end of the process to prepare to be in the big consortia. And for example, what we are doing is business trips on the most important business events on the world. Today we are at Hydrogen Summit in Brussels. We have our stand as a Małopolska region, and we ask our partners from the region there, and it is just one of a lot of examples in this area. And we are now in process to join to Hydrogen Europe, so that our way to promote region is very wide. What we are doing is preparing projects for our region. We as an organization, we are a part of the Hydrogen Europe program. Małopolska Research Night is one of the biggest program in our region. We promote to children, to young people, how science can be fascinating, and what science can offer. And we are, as a region, in a consortium with AIT Digital. In regional innovation valleys, we are in digital health. So we are a strong partner for our business in Małopolska, because we are in this project not just for us, but we are in this project for our partners to offer them cascade funding or be in the knowledge ecosystem, also in working groups or a steering committee. And at last but not least, we create knowledge about Horizon. A few days ago, we published on our sites report about Poland and Małopolska in Horizon Europe, and it was what Jacek had said. It was very sad, but there is a lot of work to do.
But to your last point, I can only agree. But also the optimistic news for you is, and this is not optimistic for the other cities that I will mention, that from 3 voivodeships that we are serving in terms of money from Horizon, Kraków constitutes 92%, Rzeszów 6%, and Kielce 2%. So you should be happy as the Krakowian representative, but you know, that calls for more spread, application map in Poland and the success rate in Poland.
Yes, but
still. Coming back, if you want more numbers, I can get you. I met Mr. Mikkel Schäfer about 10 days ago in Warsaw, and he's the president of European Innovation Council. And as you know, they're funding a lot of companies in terms of accelerator, transition, and now they have the new instrument called STEP. STEP is up to 30 million euros in investment. But I asked him about exactly this question. So location of Central and Eastern Europe on the Europe map. He says 6% of all funded programs are located in Central East. 6. So 94 are somewhere else. Out of those 6, 3% are in Poland, which is not good. And as we speak today, there are 7 companies only from Poland funded by European Innovation Council. If this was evenly spread across Europe, it should have been 42, 7 times more. So the numbers are really discouraging, and we have a lot of things to do. He identified several reasons for it. Why is it so bad, and so on. But I'm not going to discuss it. But this is as far as numbers. We are way behind, and we need to do a lot of work. And the way to get there is quality applications and more quality applications and more quality applications. And then we'll have more projects.
Okay, thank you very much, Mr.
Yeah, actually, I totally support you in that case, because I also have the same discussion with European Innovation Council about the Lithuanian topics. And there is only one company which was actually one. Yeah, so if you will try to compare Lithuania with Poland, we have more or less the same situation. And actually, it's the same. We need much more quality in the applications you provide for us. And the second one, what was said by him, it was, you know, we need much more marketing of your country in Europe. And we need actually Lithuanian Investment Bank to cooperate with one. So I would say that we need much more intensive discussion between the governments of member states with European Commission and Directorate of Research and Development as well.
So it's all about the education, about the marketing, or maybe more brilliant ideas, the courage, or what else?
Mr. Schäfer mentioned one thing. I mean, that pertains to European Innovation Council. These cannot be the, let's say, the incremental progress type of projects. They need to be breakthrough projects. I don't want to say, you know, there's a word for it, disruptive projects or something like that. At any rate, these need to be the very important projects in the very specific concentration areas of European Union. So you need to be, on one side, political to fit into those particular categories. And secondly, you need to have a very good project, disruptive or at least breakthrough and not incremental. And so that all boils down to the quality. So it starts with quality. That's it.
It was, or maybe it is still, my next question. So what should be the strategic priorities for our countries here in Central and Eastern Europe in the next phase of participation in European programs?
I'll be very quick and I will pass my mic.
Please.
As far as priorities in our country, it should be less priorities.
Okay.
Yes, yes. Currently, we have so many priorities. If you take so-called krajowe inteligentne specjalizacje. So this is a that should have been a concentration or a focus, right? I had this discussion 2 weeks ago, and I asked the audience, what area is not covered by our specializations? All are covered. There was one voice from the audience, and it was sports. Sports is not covered, but whatever. If you're in agriculture or in mining or in energy or in optoelectronics, all of that is covered. So what kind of focus do we have? We have no focus whatsoever. Thank you. The voice from audience. So now with that, we have 100% covered with specialization. We specialize in everything.
And then now survive the areas which are not in focus. They will go on to die?
No. This is
They will be now supported.
Yeah, so we are going to be, so this is incorrect point also.
So why should we need focus points or specializations? So what is the reason for specializations then?
Okay, then we have outstanding science, outstanding things. I understand that. If we have outstanding achievement for the long development, that's correct. But if we're talking about country development, and that means in Lithuania, everything's saying lasers and biotechnology, yeah, we are making fun of it already. So if you do only to these two positions, what about the rest? I mean, if they are not important, we not attract the attention for Commission to promote projects in the other areas. So what is their destiny? Are they going to die? Are they going to shrink? What happens? So coverage is a normal procedure. So maybe it's necessary to reprofile what is peak achievements, what is general achievements, how to survive otherwise. Because from bureaucratic point of view, it's very good to have a table and say, okay, 3 points we are happy to have. And then they cover all the map of Europe and they say, okay, this covering this covering this. How to survive for the country? Thank you.
I don't have the good answer except there is no justice in this world, and somebody has to die. And today, if we look at what's surrounding us, we are not putting money in, I don't know, in fancy new, however, museums were opened. What I'm trying to say, there are things which are important and more important. And we need to focus on those more importantly. Today, the war in Ukraine is #1. And I don't know, optoelectronics may be important for the war, but some other areas of research are not. And that's it. They will survive. They will not, starve, but they will not financed to achieve some new levels. The priorities are always made, always. Nothing else.
Please.
I would, maybe will be not so popular, but I will speak as a former politician. Because several years ago I was Vice Minister of Economy and Innovation, and I had the pleasure to participate in the drafting of the European Industrial Strategy. And during the negotiation with the European Commission on the upcoming European Industrial Strategy, we negotiate about the strategic value chains where the Europe can be most competitive.
Yes.
And the discussion was really wide, specifically organized and facilitated by the European Commission with the member states, with academia, with involvement of business associations. I'm talking about the European Business Association. And then Europe said that in general we have possibility to get the breakthrough via 32 strategic value chains, 32. But then the Commission, I don't remember which one commissioner said that and in which meeting it was said, but he said, we doesn't have enough money for the possibility to support all 32. So let's select 8. And then actually they said 6 we will take from you and 2 we will add from the side of European Commission. And that was, those 2 was batteries and microelectronics. And those 6 from the audience, from the Europe, was green and autonomous vehicles, industrial Internet of Things. So there arise microelectronics and then batteries. Then they said the hydrogen, then the health, and biotech and medtech together, and the decarbonization. So there was actually 8 strategic value chain for Europe. And after that, the Commission said for all the member states, now in the European strategy, we have 3 tools for you. First one, alliances. Meet, discuss, and show us where is the best way to make the Europe most competitive in those 8 areas. And when you will show us the way, we will provide for you IPSE projects with a 50% of funding from the European Union. And we will invite you as a member states and the business community to add additional 50% from your side in order to develop the infrastructure necessary for raising of competitiveness of Europe. And finally, we give you the set 1 tool. It is Horizon Europe as a program with 3 pillars: European Innovation Council for startups, global and industrial challenges for rest of industry and universities or RTOs, and for science, this open science looks like this one pillar called in that way. So there we have strategy, but European industrial strategy. Maybe you know the Polish industrial strategy deeply connect with the European one. In Lithuania, I don't know. We doesn't have the deeply connect strategy because our smart specialization is quite similar, suits quite well, but not in the right way. So we always nationally have a lot to do in order to improve our competitiveness nationally and to support the European strategy if we want to be competitive as Europe. Sorry for a long intervention.
Dracula, or you would like to add something? No, okay. Thank you.
I can only add that as an SME, we are not supposed to develop high-level strategies, but quite often we somehow are asked to contribute to different consultations or opinions, and definitely when we contribute to the definition of the smart national specializations, it was exactly collection of opinions. But then there was no second level, like what to choose, and everybody put what he thought he is good in. And then it was just a collection, and that's why it covers everything what we do, more or most of it. So that's why I think it's important to find the second level, and there should be, let's say, more strategic thinking needed. And let's say, from my personal perspective, of course, the security is quite important, and it's at different levels, starting from the crisis management, but also defense, and also the non-dependence on let's say, our providers. So these are, I think, quite critical issues. Also the artificial intelligence, I think this is a very important aspect, and we are here also to discuss about it. 2 weeks ago, I attended such forum, ARDF, it's AI Robotics Data Forum. And let's say it was Eindhoven, European one, so it's, there were just like 400 people, 4 people from Poland, so just for statistics. It should be at least 40. But again, there was seen quite big, let's say, pessimism that Europe is quite behind the US and China and the whole world. So it's, and in Poland, I think we are still behind Europe. So it's, and I don't know how it in other Central European countries it looks like, but I think it's quite significant issue, and we should put strategy here. So how to get involved into these different initiatives. And coming back to your suggestion, make more applications, and more applications. I fully agree. The question is how to do it. And for instance, one of the, let's say, ideas that we should put is to how to better get involved in the forums, which are defining the work programs, which are then making evaluations. There are these different partnerships, associations, etc. And we should be present there. Also in the good statistics. So this, yeah.
Thank you. And to your point, you both mentioned the competitive strategy of Europe. We drifted from the original topic, but we cannot, forget about it. Mm-hmm. Priorities. Speaking of conferences, priorities, a month ago I was in Bled at the Bled Strategic Forum, and we had a sitting of Atlantic Council, and this was on the Europe's competitiveness. And the takeaway was that we lost already internet, and we then lost the cloud wars, and now we are losing AI wars. We're still fighting, but this is not really successful. So where are really our chances located? So we identified in this discussion, maybe 4, and these were life sciences, mainly pharmaceuticals. Second, this is quantum computing. Also, we talked about renewable energy. We are good and maybe ahead, except everything is produced in China. And the fourth one is, to your point, hydrogen. And you mentioned America and China and so on. And as we discussed here, so many topics and for so long, so about 1 hour already, and this Europe cannot get to the conclusion, like we cannot get to the conclusion as well, because we'll not get to the conclusion here. Let's say the motto of this discussion was that America creates, China imitates, and Europe regulates. So we are regulating everything, and we are focused on the democratic ways of solving problems, which will not be solved in that way. Sometimes you need to die in order to make some progress.
So, in your opinion, countries from the Central and Eastern Europe should improve collaboration with the Western partners, or the Western partners should change their attitude towards countries here in Central Europe?
How can we change their perspective? I mean, I think we can strengthen and go abroad and go to the events and network. I was thinking about competitiveness, that we can go inside the countries at the regional level. In Romania, for example, the regional development agencies are right now coordinating the budget per region. I think maybe it's the same here. So this is a good thing. This is perhaps a first step to become more competitive and to be more open, because there are some regions in Romania that will launch open call for innovative ideas. They are more open, for example, to different institutions from other European countries or from Europe, for example, to the EIT. And I can give you an example. In our case, we are representing EIT Urban Mobility as well in Romania, acting as a hub. And what we managed to do is to actually conclude and to make an open call for the national startups and SMEs and public authorities with the agency, the regional agency from Northwest, if I'm correct, it doesn't matter very well, and with EIT Urban Mobility as well. So, and the regional agency will give €1 million or something like that to support us. And they will take the best practice and how to do it from EIT Urban Mobility. And I think this is great, this is amazing. They are open to this. So this is something that can start inside, and if the public authorities in our countries support us, maybe we can move forward to the European level and the European institutions to trust us more, perhaps, and the partners at the European level.
Okay, thank you very much. So let's go back to the support at the local level. And what actions is the Małopolska Marshal's Office undertaking to support Polish entities in increasing their participation in international programs in general?
What we are doing for supporting national entities. We support regional entities. So if we have national entities, we are encouraging them to develop businesses in Małopolska. And with our entities, we do collaborations. JOS or it's hard to say regarding to smart specialization, because it will be easier to explain for me. Of course, we have at the national level uncountable number of smart specializations. We have in Małopolska 7, but we decide to develop just 4 areas. It is health, energy, efficient energy, creative industrial, and for the przemysł. Industry 4.0, yes. And there are the topics that we are focused on. And in these 4 topics, we are looking for cooperation with other regions, with other institutes. For our EIT is our focus as well. And in this area, we asking to join to the projects. We asking to join us with meetings. It is daily work. It takes ages, and but we have effects of our work. I suppose that we are the second region after Warsaw City in the Horizon Europe program.
That's right.
And other regions are far away from us. This is the effect. Of course, it is the effect of working at the university, working in everyday business. But I think that it is the effect of our efforts to build projects, to build trust, to build potential, innovative potential to do other things in our region.
Thank you.
Just wanted to add that Urząd Marszałkowski, Marshal's Office, created something which is called Małopolskie Centrum Przedsiębiorczości, which is the specialized agency financing the, let's say, innovative research and applications, predominantly companies, and through companies also universities. So we are not talking about voivodeships supporting national strategies and national funds. We're talking about local. Many voivodeships followed and created their own agencies like this. MCP, we call it in Polish, and it's very efficient.
So it is in your...
Yeah, we are getting projects from companies as the execution part of this. This was called before Bony.
Bond for innovation.
Yeah, but now this is something different, but still, this stream of money is coming to the local voivodeship companies and through them to the university. So this is nicely structured in Kraków. Congratulations.
Yes, but I think that we should have a Bond for Horizon to prepare good proposals. It is a challenge.
That is monopolized by the... No, this is just monopolized by the companies.
What is monopolized?
Whole Horizon applications.
Oh,
Monopolized by the companies writing the applications and helping, supporting, facilitating the applications.
So it's an advantage or disadvantage to increase this?
It depends. There are 2 ways to go. My colleague is a very successful leader of a very good European Horizon program in energy with the Sapienza University in Rome and with some other universities, companies across Europe. And he won it alone with no companies involved. But he did it in the 5th attempt. So he was unsuccessful 4 times, and for the 5th time he won. So this is one way to go, and the other way is to give some, let's say, content, let's say...
I wanted to ask, writing the same project 5 times?
Different schools of thought. Okay. If you have some experience and that, and time, and if you are not scared of hard work, then you apply alone. And then you lose, and then you lose again, and then you'll win.
I think this works with every project. So we are doing this. At the beginning, we did this as well. We wrote project, they rejected it, we wrote again. So I think this is in all cases. And I think everyone should understand this. Of course, it's a little bit hard. I mean, we know here how to write project, and I think this is important, how to understand this language and their language. But yes, rejection is part of the process.
And the support, how do you, what do you think about the support, like industry contact points or the local governments in writing, such as applications or...
Support?
Yeah.
From the...
Yeah, from many institutions located in other countries here in Poland.
Non-existent.
Okay.
Yes, so I was looking at Paulina, and Paulina is pointing that she's the coordinator of EIT Manufacturing Hub here in Poland. Yes, our role representing different EITs in different countries is to help the people that want to get in touch with these institutions. So for example, yes, we are there, we exist if someone is interested to, but we are a private company and we are representing EIT Manufacturing. But there are the NCPs or the regional development agencies or other agencies that are supposed to help us in this.
Yes.
No, they are not very
Okay, so
helpful.
in fact, what specific actions are needed to improve the knowledge, to improve...
First, they need to understand how these open calls work.
You as a business side?
The NCPs, for example, or the people that are at the national level have the mission to help on this, is mainly, I think it's important for them to understand what's all about. And after that, to try to help us.
Okay.
Because there are some cases where we, as a company, for example, that writes projects, we understand better than the ones that are evaluating the project. Or, yes. And that's, at the regional level, this is what happened, for example. Maybe this is the, and we had a situation, for example, many situations at the regional level where we applied for regional open calls, and they found something to reject several projects, for example, because they didn't actually understand the topic. And the evaluators weren't experts enough on that. Let's say. I'm talking about technology transfer topics. That was in 2018. Yes, this is something that I would say.
Thank you.
Just I want to add that this is also the role of the national contact point and the regional contact points. This is what we're doing every day. We're trying to educate the scientists in not only writing, but also applying. Broader issue. We bring specialists. We bring the successful scientists from different areas. Let's say we have European Research Council. So ERC grant is something really, really big. And the ERC award was mentioned or designed as the European Nobel Prize. But so when we have the applicants, we arrange for the sessions. We bring people from Poznan, for instance, who are successful. We had the Professor Sankowski yesterday. He's the world champion of ERC. He won 4 ERC grants. Mm-hmm. So the same with EIC. We try to educate. An EIC process itself is very sophisticated, but it's great because they have like a trial or first step application. You don't have to work very hard on it. This is just like a summary. And then after the initial seeding, you're in or out. So if you're in, then you really work on your application, and so on and so on. So we do a lot of, our job is actually seminars, trainings. We arrange for 40, 50 trainings a year, live and online. Live, we have up to 50 people from all across Poland, but mostly from the southern Poland. Online, the record number for us was 900 people in such a training. So this is our role, and this is what we do. I don't see there's any role for the Marshall Office in this, in supporting the writing the Horizon applications. I don't think so.
Yes,
I would add something from the perspective of the company, because for example, in Lithuania, we also have a wide network of national contact points. We also have national contact points and representatives from agencies or ministries who participate in the program committee and know quite well the upcoming program, who knows quite well upcoming calls, and who understand very well the rules of game. But speaking from the perspective of the company, they need someone who can provide evidence-based information for them, especially for CEO or maybe for CTO of the company. What will be the upcoming call and how you as a company should work with your NDI potential in order to prepare your company to participate in exactly that call which will come, and to understand what the objectives of the call, what the impact is waiting in that call, what the strategies of the European Union should be supported via this call, and to help for the writer of the proposal to understand how your idea support their strategies, and the blue lines which normally nobody reads. Because in the documentation of the European Commission, there is a lot of blue lines. I mentioned that you should push that blue lines and to go deeply and to read the long, long document of the European Commission, what they want to solve with that call. So from our perspective, I would say that in the member states, especially in this newcomers, I still call it newcomers of the European Union, who actually during the Horizon 2020 get only 7% of the total funding, when 78% goes to the 5 Western Europe countries. So those 77% show that we are not ready to participate. And in those member states, 13 member states, we need strong support from the state in finding the right people who know the rules of game, and as a one-stop shop can work with the companies in order to help them to be prepared for the participation in Horizon Europe. by helping them to define their R&D potential, by helping them to prepare the value proposition for consortia leaders in order to show what is the value of my company, what kind of, let's say, use case I can suggest you in your project as the company, and how we will reach together the market after the project will end. So that's not so easy to explain for the company, especially on the perspective of 4 years, because the project will continue for 4 years. Yes. Thank you.
Please.
Okay. Yeah, I would like to continue on this, I think, because we started to talk about NCPs, regional contact points. I believe they are working perfectly. I mean, they spend a lot of effort, and the collaboration with them is very good, like for us as from the perspective of SME. But what we are lacking is this, I would say, higher level. So how to go, for, let's say, a level up, how to make, I would say, maybe not the right word, lobbying in a good sense. I think this is something what you also try to express, how to go up with these, let's say, ideas, how to better understand, how to also make some synergies between different activities that we are doing. So how to persuade our politicians, or how to make them aware about these programs and make them active in different bodies at the EU level, and not only politicians, but different EU officers, which are also from our countries, and how to benefit from them. I mean, the other countries in Europe, they are doing it quite well, like in the Southern Europe or Western Europe. So we should also use these contact points and also get known what is behind lines in the work program, for instance, or what is really important in the particular destination objective of the work program. So I think this is one point on which I would like to stress. And the second one, I think we still should spend some time on, let's say, at national level to make some legislation aspects, to regulations, to make them more coherent with the European ones. It's starting with some simple, let's say, somehow, because, for instance, if we sometimes contribute to national research programs and international research programs, it turns out that certain category costs cannot be applied in the same way. And this is quite frustrating. And then the same is, for instance, I will just mention one program which frustrates us quite recently. It's European Digital Innovation Hubs, which are funded from two different sources. And these are the companies and institutions who are supposed to find the solution. It's not, this shouldn't be like this. It should be between the Commission and the states to be clarified how it should work, not us. But then we are, let's say, there are some companies who even went, or the institutions who went to the court to solve it. I think, I'm sorry to raise it, but I think this is something that we should spend here at the national level and insist on our decision makers to clarify it.
Yes, it is very interesting. Mr. Wilda, you wanted to add something.
Okay. Just to continue with, because you mentioned about the European Digital Innovation Hubs. We are a digital innovation hub in Romania as well. For the Central region in Romania, we are partnering in another two. The thing is, you know that the funding came from the two sources, the European one and the regional one. The regional one was very late. And we tried to help and do, and not to start, but had to start, even though we didn't have the money. And we are trying to do something at the national level. We do have the services and getting in touch, but we need the help as well of the national institutions on this. So again, we are back to the national institution and the public support, the public authority support. There are these institutions and the projects like the European EDIH, which are for this, for the years that they are still, you know, when they started and right now they're finishing, I think they were an experiment. They will continue perhaps some of them, but they were an experiment. Just wanted to say something about the horizon. There are some organizations like EIT Manufacturing who are organizing webinars or workshops on how to write project on Horizon. Of course, we as a company, we know how to do that, but for example, for the companies or organizations or institutions that don't know how to, they are doing that. So this kind of organizations and edX as well, I think they would be open to organize something on this topic, how to write, because they have the access to funding work package, so they have to. Thank you.
Thank you. You know, I just listening to you, and one idea was in order to add what is said by you, from the side of European Commission, they have money and they want to invest. From the side of business or academia, they have an idea and the project. So when we are talking about the rules of game, we should change a little bit paradigm that Commission actually, or NCPs who represent Commission, when they speak with university or when they speak with the company, they should speak like with the investor who has a project, who has own private money, and who will invest without Commission. But if Commission will want also to earn money and want to invest, they should speak with the company and university with an investor about the feedback, about the return of investment, not only about the impact. So that will change totally approach if we will change paradigm. Now, they think that we are looking for subsidies. No, we are not looking as business, we are not looking for subsidies. We are looking for co-investor. And we would like to speak with them with a co-investor, and we would like to spend our money on our own rules, normally rules which is in the culture of industry. In the culture of business, not with the rules of European Commission with a lot of papers. Because you said you are digital innovation hubs. We also digital innovation hub. And we provide actually services for industry on B2B basis, business to business. And normally when you provide services as business to business, I give you an offer. You take it, and we will sign an agreement. Then I will provide you report and the bill, invoice, and you will pay money for documents. As a digital innovation hub, when we provide the value for business with a state aid, we need 24 documents. So you can imagine that in that case, some services, they are too expensive in order to provide with the state aid. Mm-hmm. And the investment from the European Union via the state aid, it's not so successful than it can be. Mm-hmm. Yeah.
Well, the discussion is, yes, please, Mr. Kash.
Just wanted to add two things. This venture capital mentality or approach that you have just mentioned is already present in the European Union dealings with the universities, most notably in the European Innovation Council, because these are really looking at businesses as the investment and investors, and they are talking about the capital investments up to 30 million euros. These are quite serious money, and they really are looking at the return on investment. This is one remark. The second remark is, I'm not sure if This discussion has been going on since I've been in this business around from the 90s. So we are talking about it for 25 plus years. And what you have just mentioned is that was nicely paraphrased yesterday in this conference. Have you been to the other session? There was a panel discussion on, I guess this was on energy, but at the end of the day, it all boils down that the problem between academia and business and how to connect both. And my God, we are open doors for 25 years and so on. And in the last words, one sentence everybody had. This Professor Kurek of the National Nuclear Center said very nicely, and he was applauded by the audience, that don't look at us as the cost, look at us as the investment. And that's what he said, and we are saying the same as long as I remember.
Thank you very much. The discussion is very, very interesting and hopefully helpful for the audience, but unfortunately we have to conclude somehow. So my proposition is to conclude the discussion. I would like to ask all of you, our dear panelists, for 2 or 3 sentences as a recommendation in using Horizon program to the audience. And in fact, what do we need more? Courage, patience, good partners, like, for example, branżowy punkt kontaktowy, the industry contact points here based in Poland, the local governments, or just brilliant ideas?
I think we need smart plan how to be in Horizon Europe. Smart plan in which we are looking with courage at strong partners, sharing our ideas, and prepare with patience good proposals.
Thank you.
I would say 2 things. One is, don't open the open door. When I joined this, let's say, nicely, ecosystem about 25 years ago, one of the first papers I read was by Professor Witold Orłowski, and he was talking about a sensational thing, which was the different language that scientists are talking against the business, and they cannot communicate, and how to bridge this gap, you know? And now, after 25 years, last week, there was a sponsored article in Rzeczpospolita by Professor Orłowski saying, we cannot communicate with business, you know, and how to bridge this gap. And the conclusion was we need to one nationalized, centralized technology transfer office. While this is quite opposite. The lower we go, the better. We need to talk to individual scientists, individual companies, and not do it in Warsaw in the governmental buildings. It's a nonsense. So this was first remark. And second, I will just repeat after Professor Kurek, because he said it nicely, don't look at us as the cost, look at us as the investment. That's it. And everything then stems from this. Horizon, EIT, whatever, is a result of it. Maybe 3, may I?
Please.
The third one, nobody said it yesterday because the people were ashamed because they were government and so on. Since the revolution of '89, we don't have the long-term science and research strategy in this country. And unless we have one which is continued from one government to another through all the changes in politics and in governments, long-term, continued, executed, we will not succeed. That's it.
Okay, just so how to increase the contribution to EU programs, in particular Horizon Europe.
How to encourage.
Encourage, yeah. I would stress that 2 points. One is let's say, have more horizontal collaboration. Because if we go together, then we will be stronger in Europe. And the second one is if there are any ideas to support organizations in participation to these programs, keep them simple. Don't, let's say, make them complicated, because sometimes when we need to fill in all these forms, then people just give up because it's just simple 2 points.
Thank you for that opinion.
I think courage and good ideas. You cannot go into the market with the plan to open a bakery. I mean, a bakery is good, but it's not innovative enough. So yes, courage, go meet people, events, network, and so on and so forth, and have qualitative idea and a project idea.
Thank you.
Yeah, thank you very much. I would say that, by the way, I strongly support you. Let's simplify procedures and reduce the bureaucracy. And especially for those regions where the small companies participate in the projects, because administration burden is for companies, it's really challenging. And then I'm strongly support you that just ask and people will give you an answer.
Thank you very much for being with us today. Thank you to our panelists for that interesting discussion. So thank you very much. Stay tuned for the next steps of this conference because there are still interesting topics ahead of us till 3 p.m. as I remember. Well, okay, so thank you very much.
And before the lunch, we have one more presentation. Okay, picture time, no problem. In the meantime, I will introduce our next speaker, who is one of the panelists here. We will have the presentation, Success Story in Horizon Europe Program in ITTI by Krzysztof Samp, one of our panelists. Thank you, everybody. Krzysztof, the floor is yours.
Okay. Okay. So once again, still, I think I can say, I probably should say good afternoon to everybody now. It's really, let's say, a challenge to talk after such nice panel and with a lot of inspiring talks and ideas. So I will, how much time do I have, by the way? 15 minutes. Okay, so I'm the last one before lunchtime, so I will try to keep it short. Okay, so I will briefly present our company, our story in the Horizon Europe programs and some other programs, and I will finish with, let's say, a short description of two projects which are, I believe, in the scope of this conference, in particular in the automation and artificial intelligence, and with also some small remarks at the end. So who we are? We are an SME from Poznań. We also have a small affiliation in Bydgoszcz, which is like 150 kilometers away from Poznań. We are 75 people, so we are typical SME. All the shares are owned by the people who work in the company. And we are doing mainly software development. So we are kind of a small software house. And we are doing mainly customized software solutions at the commercial, let's say, market. And we usually make digitalization of non-standard processes, like, for instance, management of recipes in the cosmetic company, or management of processes in the company which deals with electronic wastes. So this is just to give you some examples. The second part of our activity is dedicated to space, and we work mainly with European Space Agency as well as with European Software Observatory. So this is a body which governs big telescopes which are located in the southern hemisphere. And we are doing mainly software either for engineers or for astronomers. So this is very briefly about our activities. And the third part is mainly dedicated to, let's say, what I'm supposed to talk is about applied research and our involvement in R&D programs, particularly at the EU level. We are supposed to be one of the most active Polish SMEs. That's why we were awarded several times such nice Crystal Brussels Prize by our national contact point. And what I would like also to stress, we are also members of several associations at the national and international level. We are, for instance, members of ISTEC, so that's why we are also attending this conference. But we are also members of some other ones. I will maybe just mention 6G Smart Networks and Services, which is kind of a partnerships focused on 6G networks, and EXO, which is European Cybersecurity Organization, which deals with cybersecurity at the European level. And so far we did over 60 projects in Horizon Europe program. We are mainly focused on, let's say, public security. Our main areas of competencies are data fusion, CBRN, which means chemical, biological, radiological, and nuclear protection against these threats, crisis management, digital decision support systems, also cybersecurity and application of AI and machine learning in these aspects. Also wireless communication, which is our original competencies, because when the company was started in the mid-90s, we were mainly telecommunication engineers, and at that time it was the era of 2G and 3G, and so the company was started at that time, but then we, let's say, evolved to other areas. We also have some experience in e-health and Industry 4.0. But coming to this, our story, I briefly said it in the panel, so we started, quite long ago. It was over 20 years. It was framework program number 5, and we just joined ongoing projects. I can compare it now, it's to this widening program or hop on. It was called differently, but it was a similar idea. Then, let's say, when we got a little bit settled in these programs, the 6th framework program came. Poland was already there in the EU, so we managed to apply just as a normal partner, and we became a different partners in different consortia. In the meantime, there appeared such program called PASR, which was Preliminary Action on Security Research, because at that time Europe didn't do any research in security, at least in more, let's say, systematic way. And it was just a start for 7th framework program, in which security and civil security became an important part. And it was, this PASR was quite good start for us to enter. And this is again one of the, let's say, patterns that I can see, that if there is something new, then it's easier for newcomers to enter. Because if the ecosystem is already settled, then it's quite difficult to enter, because everything that is somehow managed and dealt. So when there is something new, there is a new opportunity. So we joined this as, let's say, as a regular partner, and almost at the end of 7th framework program, we became a coordinator of the first successful coordinator of the project called Camino. Then in Horizon 2020, we already had two coordinations. And in Horizon Europe, so far we have one. We applied several times, so we hope this number will increase. I can also add that we see some synergy with other programs, like, for instance, EDF. There was also such program, PADR, which was preparation, then EDIDP, next step, and now we have this European Defense Fund. We have 2 ongoing projects in this program and 2 more in brackets, because they are under negotiations, and we keep our fingers crossed that we will start them next year. This is, let's say, a bit about our history, and I can say that when I look for it from this, like over 20 years of this participation, I can see like 3 main phases. The first one, we were just, I would say, still observer. We made some supportive roles. And at that time, the company was mainly doing telecommunications consulting. So we had some synergies with working for particularly telecom operators. Then after the year 2004, we extended our activities to IT consulting. We have found also some synergies with these activities. We also started at that time to work for EDA, European Defense Agency. And recently, and we became at that time, let's say, just a regular partner. While now we are we at least try to be more and more involved in, as we call it, core team of the proposals. So just to be maybe not exactly a coordinator, but among the smaller group which defines the scope of work. And this is our ambition, how to position ourselves. We also see some synergies with the, let's say, commercial activities, with the work for ESA, a European Space Agency. And definitely what I would like to stress is that, let's say, at least in our case, the Horizon programs and framework programs helped the company to transfer from the, let's say, one activity, which was mainly first telecom, then IT consulting, to software house, because in these EU programs, we were able to build the competencies in software development and then to apply it at the let's say, commercial market. So this is, let's say, a little bit the story behind our contribution to EU programs. And then I would like to say a few words about two ongoing projects from the Horizon Europe program. The first one is called Ultimate, which is multi-level trustworthiness to improve the adoption of hybrid artificial intelligence. It's a relatively small project. It's like only 10 partners. From Poland, we have Łukasiewicz Network, PIAP, and ourselves, ITTI. The coordinator is Thales company. We have like 3 SMEs, 3 RTOs, and then two big industries. So it's, I would say, quite nice project. It's not too big. It's easy to manage, easy to work. And the ambition of this project is to develop, as they call it, industrial-grade hybrid AI. By hybrid AI, it is meant the combination of the, let's say, data-driven approach and model-driven or symbolic-driven approach. So the idea is to combine these two approaches in order to have better effects and or not to use as much data and computation power. So it's better train these different models and apply it in the manufacturing. So the project has just nice 3 well-defined pillars: design and development of some of the architecture, or how to construct and train the hybrid AI algorithms, then how to evaluate them in very, let's say, specific and precise way, and then to apply it in the pre-industrial or pre-operational environment. So in order to build the trustworthiness, which is, and understand at least 3 levels, like validity, explainability, and ethics, which are all 3 are quite important. So this project has 3 different use cases. One is related to space. 2 others are related to manufacturing, 1 to robotic arms. The third one is more also focused on the, let's say, robots in the working environment. And here we collaborate with PIAP in one of the use cases. PIAP constructed a nice workshop in which we are, let's say, building a model and a system which detects anomalies. So we are using, again, this hybrid AI, in particular deep neural networks, to analyze the position both robots and the human. And then we apply different rules to identify whether the robot should be stopped. This is, let's say, very basically, in order not to make any harm to the human. So, and we are using this, let's say, analyze the object, the source from different cameras and different sensors, and then build, let's say, nice models, and build also this anomaly detection system to protect the humans. And this is still an ongoing project. We have nice first results, and we are looking forward to some follow-ups, because these projects will finish at the level probably 6 or 7 of TRL. So then it's still time to and effort needed to further evolve it. And the second project, which I also would like to very briefly mention, it's called Chimera. It's the project which we are coordinating. It's in fact the result of 2 previous projects, EU Sense and EU Radion, which were done in Horizon 2020 and were also coordinated by us. This is project which, when we started almost 10 years ago, this topic, CBRN protection, was a bit abstract to us. But now, because of the war in Ukraine, we see that this is very, very important, and we should be much more aware about it and work on this kind of solutions. And we are already using some, because we already built competencies in the, let's say, data fusion from chemical sensors, from radiological, and in this project we want to extend it with biological sensors, apply it in, let's say, urban environment, apply it, we already did it at some UGVs, you can see some, we already have 3 UGVs in ITTI, which we are experimenting, but we'll also plan to have some, to make them under flying vehicles. In this project, we have a partner, which is Japan Atomic Energy Agency, the one which dealt with Fukushima events, so we also expect to get some experience from them. And we are also heavily working on the commercialization of the results of these projects, of the outcomes. So if anybody is interested in this topic, I'm more than happy to further discuss it. And coming to the end, so very briefly, definitely these EU programs help to support the company in this transition from one activity to another. This is definitely something that we appreciate very much. Of course, I would like to stress that at least mid-term, but in fact long-term approach is needed. You need a lot of patience with these programs, and you need to also know your way how to do it. You have to be flexible and open. It's one needs to like to collaborate, because if it's not, it will not work. So it's important. Another issue that I wanted to stress is the credibility. This is a kind of a side effect that we got from these programs that we didn't expect it in the beginning, but after being partner in many projects, it turned out that it gives us a lot of different possibilities. And also, if we go anywhere and we can claim that we collaborated with such partners in such environment, we already got support from different EU bodies, then it's really a good, let's say, opening way for further talks. And of course, last but not least, people are very, very important. It's not that everybody can work in these projects. You need some special staff who likes this job, who likes to develop themselves, and wants to be there, because it's a bit industrial approach, a bit scientific, a bit business development. So these are different skills are needed. And I will maybe conclude that the commercialization, of course, is a challenge. These projects are not. They don't provide ready-to-use products. So you have to remember about it, you have to explain it to end users, to different, let's say, potential customers. There is still a gap. Whether it's a valley of death or it's another, let's say, Martian dive, but it's definitely we should keep it in mind. Yeah, that's all from my side. Thank you very much for your patience. Thank you.
Thank you very much. Before you go to lunch, some logistic announcements. So the lunch is served on the floor -1 for those who have invitations, and lunch lasts until
We can start. We have my presentation for now. Once again, my name is Paulina Jasińska. I am from Łukasiewicz PIAP, and I'm coordinator for EIT Manufacturing Hub Poland. And this is the project in our institute. And today we have for you two quick presentations about our two hubs, actually. Mine in Poland and also one in Romania that Raluca Lukat, who's joining us today from Romania, will talk about. And then we have short workshop, kind of scoop that we want to introduce to you the idea of open innovation projects. And next year we want to invite you for the big and proper workshop, how to do it and why it's an important idea. So let's start. We can start with the idea brought us by EIT Manufacturing, who defined 5 biggest challenges that face the industry. It's skill gap, lack of diversity, linear production models, high GHG emission, and insufficient resilience. And for those questions, EIT Manufacturing is trying to find a resolution. And that's why those are 5 main points of interest. And who we are, and what is EIT Manufacturing? It's a private-public partnership in European Union. The headquarters is in Paris. It has 6 regional offices, and those called CLCs. And our Polish one is with headquarters in Darmstadt. The main idea of founding EIT Manufacturing, which is based in a 3rd pillar of the Horizon Europe, it's the triangle of the knowledge. It's innovation, education, and business creation. And here you can find this triangle with the risk component. The risk component you can think about like all of those points, but in the smaller version for the countries that need a little bit help to emerge, to make it better and bigger in the industry. And here on this map, you can see all of the EIT risk hub in Europe. Here, of course, we have, no, it's not working. We have Łukasiewicz PIAP, and here we have Romania and Iceberg that our guest is coming from. Then, why the project is in our institute? Because we are institute founded in 1965, and we have a lot of years of experience in automation, robotization, generally in industry. And EIT Manufacturing is one of our projects since 2020. And few words about EIT Manufacturing, like the partnership itself. It has more than 80 core partners. 58% as for a date March of 2023 is from industry. Universities are 23%, and RTOs, it's 19%. This is a kind of interesting point that 44% basic skills of the workforce are expected to change over the next 5 years. That's why the EIT Manufacturing is a partnership that also has services for its members, and it's trying to help with this big question. Here you can find some proposals. We are trying to ensure commercialization of the success, improving environmental stability. We also focus on Industry 5.0, which is bigger and better idea of Industry 4.0 with a human in the center. That's why the last point is also developing skills and well-being of the employees. Here you can find 4 main areas of the support of the EIT, and the most interesting ones should be for all of you the second one, stimulating the real innovation, because there you can really find money in yearly announced call for proposals, which is not huge but really supportive funds from EIT manufacturing for developing your for developing your new ideas, and you can find there also commercialization. And the fourth one, we can actually talk a little bit more, as I am also the expert in ICP Point Industry 4.0, which is organizer also of the CETEF, our event. And you can see why this project of EIT Manufacturing Hub is in the same department as ICP Point, as we are trying to help the Polish entities to gain as much as they can from Europe, from Horizon Europe. And this will be my last slide. And it's not like I wanted to show you all of my amazing pictures, but maybe a little bit. But you can see that we are joining a lot of events, we are joining networking, matchmaking, we are applying and applying for EIT manufacturing calls, and we are doing a lot of panels, a lot of workshops that you can join us there and gain a lot of knowledge and a lot of experience. So I strongly suggest so you could follow us. Here on this QR code you can find our LinkedIn of the ICB Point, which is shared with EIT Hub Manufacturing Poland. And then you can find the latest information about what are we doing and how you can how we can provide you with help with that. And that's only a few words from me. And now I would like to introduce Raluca Lucat from EIT Manufacturing Romania, who will also briefly tell you about their experience and then give you a scoop of the main topic of open calls projects.
Thank you. So, hello everyone. A lot of us today here. So I'm Raluca Lucat. Do I have to use this? Okay, so I have to use it. So I am Raluca Lucat. I come from Iceberg Plus in Romania. I am the coordinator of the EIT Manufacturing Hub there in Romania. I'm also project officer, a project manager, so I'm coordinating multiple projects in Romania, in Iceberg Plus actually. And I have to, okay. Paulina mentioned that and she made a short introduction about EIT manufacturing, and that Łukasiewicz, the hub here in Poland, is connected to Darmstadt. We are connected to Greece. Okay, as you can see here in the image, we are connected to the CLC Southeast. CLC comes from co-location center. It's not that useful information. About our company, we have more than 14 years experience in working with governments, public institutions, large enterprises, and SMEs. And starting 5 years ago or something like that, we began to work with startups as well, and we have different programs for them at the national and not only. Our services. Funding and project management. So at the core, we are a consulting company. We write and implement different projects on EU funds. We offer consultancy and technical assistance, innovation and technology transfer. We run our own technology transfer center accredited, and we offer digital transformation services. Some of the partners and clients that we have been working with multiple institutions from the national level, public institutions from the national level. I'm talking about the Ministry of Education, the Ministry of Culture, the Authority for Digitalization in Romania. We are representing in Romania not only EIT manufacturing, we are representing urban mobility, so we are acting as a hub and we are a partner of urban mobility. We did act as a energy hub as well, and we are connected to EIT Health as well. And next year we will act as a community officer for all the EITs in Romania. So we will cover all the EIT community. I don't think Paulina mentioned. EIT comes from the European Institution of Innovation and Technology. It's an institution founded by, the money comes from the European Commission, and this EIT has several innovation communities on different domains. Domains being urban mobility, manufacturing, energy, health, culture and creativity, digital. There are 9. So this is why EIT, urban mobility, manufacturing, and so on. I'll move forward. Some of our projects, we are an European Digital Innovation Hub. We are coordinating one in the Central region of Romania. We have some project on Horizon. We are representing urban mobility. We are a partner in another 2 European digital innovation hubs, and we are coordinating an EIT manufacturing project funded. It's called Twin Transition Accelerator, and I'm going to talk about it later. It's a project that helps startups and SMEs in Europe, let's say, mostly in risk countries. Risk countries are the ones that are low and moderate innovative countries in Europe, meaning as Romania, Bulgaria, Hungary, and so on and so forth. There are many of us, and Poland as well. EIT in Romania, I'm not gonna bore you with this. What we did as a RIS hub in Romania. In the beginning, so we began a RIS hub in 2020, and what we wanted to do is to connect and to make the EIT manufacturing known to everyone in Romania, but mostly to connect it with the public institutions that are responsible with publishing open calls, let's say, managing money. So managing authorities in Romania. And we did sign some MOUs in the beginning, made some events. We did sign an MOU with the Regional Development Agency in the Central region of Romania. The regional development agencies are responsible right now for the funding in their region. You have this in Poland as well, as far as I understood, meaning that the Regional Development Agency is responsible of the open calls that are launched at the regional level. I don't know what are the regions here, but you are supposed to have that as well. In 2022, we signed an MOU with the Ministry of Research, Innovation and Digitalization. The idea is for them to acknowledge that this support and community exists, and we can do something together at the national level for the startups and SMEs and innovators in Romania. And I think that's it about our RIS Hub. We have another information. We have, starting in 2022, we began to organize a pre-acceleration program for startups and SMEs in Romania, manufacturing startups and SMEs, and we have been doing that annually. We are organizing for 2 months different workshops, dedicated workshops, and after that mentoring sessions for the startups that are participating in the program, and we are helping them mainly with know-how, access to the IT manufacturing community, and access to different companies in Romania, because we have partners such as Siemens Romania, Schaeffler Romania, different universities in Romania that are helping this startups and participants in the pre-acceleration program. Moving forward, I mentioned that we have this project funded by EIT Manufacturing. It's called Twin Transition Accelerator. We are 4 partners in this. Iceberg Plus is the coordinator of this project. There is Inestec, a partner as well. Inestec is from Portugal. We have the Slovak University from Bratislava. And we have Teaching Factory Competence Center from Greece. And what we are doing is actually to help the SME startups and scale-ups and individuals from these countries. I have to drink something. For 100K, there are 3 phases: online workshops for them, physical boot camps, and coaching on how to develop a go-to-market strategy for them. And I think that's it about the project. We are moving forward to the open innovation process. I have to take 2 minutes because I'm dying a bit inside. It's okay like this. So I got a cold, I'm sorry. The weather here is not helping. It's making it greater. Okay. If you have any questions for me, curiosities, we are a few people here, so you can ask me anything about what I showed you. No? Okay. Moving forward to open innovation. If you were in the last panel where I was here as speaker, please join us. We need more people. Oh, you're leaving. So we mentioned in our, I think you've heard in other panels and in this forum that we need to collaborate. The government or the universities or the private sector wants to collaborate with the universities. And we are trying to find ways to collaborate. Well, open innovation mechanism or open innovation, it's what we can do in order to collaborate. What it's doing, so the whole process, it's actually about actions to facilitate the introduction of corporates or large companies to the startups, meaning technology providers, and universities. Because, as you might know, the universities are developing different products inside their university, or they have, processes, products, and so on and so forth. And the large companies are dealing sometimes with some challenges. They have those challenges. And most of the time what they are doing, they are going inside their company. For example, I'll give you an example, Schaeffler. If they are dealing with something or they need to develop a technology or something like that, they are going inside Schaeffler. They are going in Germany, they are trying to find that technology. But we can help them at the national level. Maybe we have a startup, maybe a university has already developed something, and we can facilitate this cooperation. So this is what open innovation is talking about. The idea is to create a context for all these stakeholders to collaborate. Okay, EIT manufacturing can help with that, with matchmaking events, different workshops on different topics. They can facilitate this interaction and collaboration. Just to give you an idea, this year in April, we organized such a workshop. This is what we will try to organize next year, perhaps at the forum. And what we did is we asked the large companies in Romania, some of them, meaning Schaeffler Romania, Siemens, FEV. We asked them to tell us some challenges that they are facing, just to name a few. We gathered them and we invited at the workshop technology providers, startups, innovative startups, and universities. And at the workshop, we presented them the challenges. They voted, they split into groups, and they started groups, of course, with a challenge owner, meaning a large company, a technology provider, minimum a technology provider, and university. And they started working on that challenge. The main purpose on this was for them to develop a project at the end, a project that could be funded by EIT manufacturing. Or not only, because today we were discussing about Horizon. You can fund such a project through Horizon, for example. So this is what we did. You can see it there. We facilitated, yes, you can see. And I'll just give you some examples of challenges. The transition from the classic car to the electric vehicle in the context of electric mobility. What impact does it have on the entire automotive value chain? We are collecting more and more data, both in manufacturing and in vehicle use. What do we do with this data? So these kind of challenges we mentioned there, and they voted some challenges, and they gathered and started working. You can see that there's automotive mostly mentioned, because in Brașov, where we are coming from, in Brașov, Romania, we are strong on that. We have large companies and German companies focused on automotive, and this is why it was a hot topic. But the topic can be different. And in Romania, we are trying right now, and what we are doing is to develop platforms, different platforms, that will do this, will cooperate the open innovation, the open innovation process. We will use this open innovation process in that platform at the national level. Okay, we use some charts. The idea is for them to develop a proposed project, let's say. You can see here, perhaps. Working group number, challenge number, because the challenges had some numbers. Names of the participants. I have to mention the people, most of the people present in the workshop didn't know each other. So it's important to facilitate this for them. And short description of the proposed project or, proposed solution. And I think this is it. Yes, Paulina.
So I have a question. I hope that our audience also we've came up with something. Raluca, could you tell us what was the result of those workshops, if there was exactly any project, something like that, that maybe got funded, maybe not, but they got a really strong consortium in real life?
I didn't follow up on them very well, but I remember after the workshop, I did follow up with everything and the information, what were the outcomes. But I remember someone from Schaeffler came really happy and was like, this was, because the large companies and every person we are inviting in such events, we are always telling them, come and speak, present us something. They are bored of that. And honest, yeah, I will be as well. I know that we were discussing with them and they told us if there is a startup in Romania, in Brașov, that can give us the solution that we need, I will go inside the company and tell them that we have it. More than happy I will do that and not go inside Schaeffler and look for the innovation. So this is what we are looking for. To cooperate and to help the small innovators, and not only to collaborate with universities and large companies. So I know they were happy with the outcome.
So let's say we have a few startups, some few small companies, and what you can say that the large companies are really want to use their knowledge, want to work with them, because like we always encourage them, we always tell them that yes, there is a place for you, but from what you're saying, they really want to use it, right?
Yes, I think if you offer them a context, a reliable context, and something, not only words, yes, and they can see the value in that, there are some openness, for sure.
Okay, so that's definitely sounds like a plan. And could you maybe tell us just a little bit about the structure of this workshop? Like they are, for example, starting with, I can see identifying the problem and the problem solution and employees technologies. So they are working on the real life problems with the real life solutions. And if not, could they make something up or?
The idea is to work on something real. When you're organizing a workshop or something public, not all the companies will be open to tell you their challenges, because they don't have challenges, they don't have problems.
Of course.
Nobody has problems. But maybe there are some of them open to name some challenges. The idea is to create a safe environment for them to work. It's for them to see that we can find technology providers here. We can write a project together. We can collaborate. For them to see that the universities are open. I saw that here in Romania, not all of them are open. And they have technologies there and they are developing, but they are not open to the outside.
So do you think maybe there is an option to, after this workshop in Romania, let's say we will do next one here in Poland, can we somehow also contact those two groups? Can we, for example, give them the same topics, the same challenges or similar? Because we are in the, the spirit of Horizon Europe, not only working inside the country, but with the whole Europe. Can we do on this, this idea really the project for Horizon?
Absolutely. This is a starting point. So, for example, how we can work next year for Poland, for Krakow. You can ask some of the companies you are in contact with, the large companies, manufacturing companies, to tell you some challenges. After that, you are inviting at the workshop startups, technology providers, meaning universities. you have to pick them to be suitable for the challenges. So for example, if you have challenges from automotive, you won't bring a technology provider from food. Because, yes.
Potato, potato.
Yeah, that's the idea. And after that, you gather them and you are voting the challenges, and everyone is gathering in groups and working on that.
Yeah, so that's amazing. That sounds really promising. And I know, unfortunately, we don't have the time today to really dig in this topic, to really have this workshop, as we also, unfortunately, don't have everybody that should be necessary for this kind of project. I mean, we don't have all of the stakeholders here, but please, if you do have any question for now for Raluca and for me, please ask Raluca. And we will be happy to answer all of your questions. And I really hope that we can stay in touch. And the idea of this open process innovation could really stuck with you, and you could join us next year, probably in Warsaw, let's say, as we have a really great institute in Warsaw, but it's not a problem for us to make, I believe, few of them in Poland. Maybe we could even organize some study visit to Romania, as Industry Contact Point had a study visit to Brussels this year. So that's the plan for the next year. That could be this.
Yes, for sure. And EIT manufacturing has different open calls that facilitates this kind of collaboration and cooperation. So the main idea is that after we are starting something at the workshop to move forward to submit the project, perhaps. But yes.
Yeah.
Thank you.
And maybe somebody has any questions, please tell us now. If not, I just wanted to add that you can always find us on LinkedIn, me or Raluca, or our ICP point. We can always connect you with anybody that you need. You can also use our industrial contact point, as this is one of the things that we are doing right now. And from the EIT manufacturing point that we did not tell you about, this is also pretty interesting. As we are two women standing here, EIT manufacturing is supporting not only companies, not only institute, but also the scientists and the sole persons, that innovators. So if you have small company, if you are female leading the company, you can also gain some funds, some fame. I've lost my
support and access to community.
Yeah.
Yes.
And definitely look up at all the instrument of the EIT manufacturing, as there is a plaza that you can use. There is
Agora.
Yeah, Agora. Maybe you could tell a little bit about Agora, about the connection to this concept.
So Agora is the platform of EIT manufacturing. It's their open innovation platform. This is how they call it. It is an open innovation platform. It works, I like to call it like a LinkedIn. So you can connect there. You have to be connected to the manufacturing domain, of course, to be welcome there. It's a big community on that platform. For example, if you are a startup and want to pitch your idea, you can pitch your idea on that platform. If you are writing a project and you are looking for different partners, you can look for different partners on that platform. So it works like this. Agora, you can Google it, Agora EIT manufacturing, and you can find it. I don't have anything about that, but that's their platform as well. They have an education platform right now. It's called EIT Manufacturing Academy, if I'm not mistaken. It was called Skills Move before, but and they are organizing different education content, like courses and trainings and so on and so forth.
Yeah, and definitely remember, if you are connected to some kind of university or higher education, the IT is always trying to find some opportunities to learn, to teach others, not only to teach, but also to learn. And they are opening some kind of courses, some kind of doctoral and master schools. And now in Poland, we are in the process of maybe opening one of them. So please have that in mind. And we have a lot of other information and opportunities. So please do not hesitate to contact us via mail, via LinkedIn, or please do find us here during networking. And we are also here for the matchmaking. So, the question, yeah? 1 second.
Thank you. You mentioned these open calls. Can you tell us a little bit more about them? What kind of projects are going to be funded? For what kind of applicants is it designed? The deadlines, the rules of funding, and so forth.
Yes, I can. So EIT Manufacturing has an annual open call. They have a lot of competitions, open calls, little ones, but this one is the main one. It works like Horizon. It's not quite Horizon.
But in a smaller version.
And the project can be submitted in a consortium, minimum of 3 partners. Mostly, if it's an education one, you have to have a university on board. I'm not getting into that, but there are supposed to be 3 partners from the industry, a university partner or RTO, and sometimes an SME, for example, an end user. Mostly the open call is launching somewhere in April or May each year. So next year probably will launch in April 2025. Will launch in 2025, and it's called Open Call 2026. Why? Because the activities are supposed to start next year and to be implemented in that year, for a year mostly. So the projects have to have 12 or maximum of 18 months of implementation period. The budget is somewhere between 400K or 500K for the whole budget, for the whole project. Sometimes with 15% co-financing or 30% or nothing, no co-funding. The no co-funding open call is mostly for the countries that are race like us, Romania, Poland. What else? What other details? The topics, they are announced somewhere in the beginning of the year, because EIT Manufacturing works on the
triangle. The triangle
yes.
includes this knowledge, so the topics are mostly focused on this triangle, so education, business creation, and innovation. Those are like 3 main topics, and under that you have subtopics. This year, for the 2025, it was a lot of AI topics. And also there is a 4th topic about the risk. So the risk, as we were showing you earlier, is, let's say, smaller triangle for those countries that need a little bit help. And it's good for us because we can say it's a little bit easier, the money are a little bit better, and we can count on a lot more support. And about this call for proposal, as Raluca said, it's every year. Sometimes, if not all the funds are used, you can they can even do it twice a year. There was a case last year. And if you are interested in this topic, please do contact us, because also, we as Łukasiewicz PIAP, we are partners in EIT manufacturing, so we can help you find a lot of partners. As Raluca and Iceberg Plus, they are, we both are applying for this calls, and you can use our connection and our activities to really do something good and promising there. I hope I answer your question. Please find us and give us info if you want to learn more.
As an example, the Twin Transition Accelerator project that I presented is an EIT manufacturing funded project. So we applied and we won. It was on the risk component to help the risk countries. But there is the innovation component where you can apply to develop a technology or a product. And there is the education component where you apply to develop a course or a training program. And they have multiple mechanisms besides the co-funding sometimes. There is the financial sustainability. I'm not saying to scare you or something, but there is this mechanisms as well where you have to prove that you will, for example, if you are developing a product, you have to prove that you will sell that product and make revenue. And you will give to EIT manufacturing a percentage of that revenue. This is a condition of that, of the open call. I hope it helps.
Okay, any more questions? If not, that's, yes, once again.
So maybe one more. In case of your project, the accelerator, how does the percentage of income work? I mean, did you have to enter into such deal with EIT?
Very good question.
Next question.
We don't have co-funding. I'll start from there because it's a risk project and they didn't mention any co-funding. We did have, but they give you, you know, that every call has a guideline. And in the guidelines, they propose 3 mechanisms of financial sustainability. One, to give a percentage, 15% or something like that, or to give them 90,000 euros or something like that in 3 years. Or to create a startup that will act as the entity that will sell the program from now on, and to give them 15% from that startup. I'll give you our situation. It's something that's happened on this. So we chose that. We chose to create, after starting the project, to create a different company that will act as a different entity to sell the program. But we didn't move forward with that because the EIT manufacturing realized that it's not something suitable for them in terms of financially speaking. So we are not giving anything to EIT manufacturing. It's a good scenario, but most of them, I think this was an experiment for them as well with this risk. But most of them are to give them 90K or 15%, depending.
So it's still a pretty good deal, and one good advice we do we can tell you that this is a good idea for funding for like the innovation part for innovation that you already have, or you need just this final kick and final boost of the money. It's relatively easy to find those money if you have already something, but it's not supposed to be only this case. You can definitely try with some ideas, and you can contact with us so we can work on something together. So I guess that's it. And thank you everybody for joining us here today. And now we invite you to the university, Jagiellonian University. We were there yesterday, and then we have the closing session and of course the matchmaking. You can still have some meetings today via B2Match. And that's it from us today. Thank you, everybody, and keep in touch.
Thank you.